Hello there, and welcome to Life Beyond Seen, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we are slipping beneath the surface of the sea to spend some quiet time with one of the most feared animals on Earth, the orca. Not the largest hunter in the ocean, not the ugliest, not even the one with the sharpest smile, and yet somehow the one that seems to make the rest of the marine world think twice. And really, that is saying something in a place already full of sharks, giant squid, crushing depths, and creatures that look as though they were designed during a power outage. Because when people think of the ocean's scariest predator, they often picture a great white shark cutting through the water like a serrated submarine. Or maybe they imagine something from the deep, all teeth and bioluminescence and deeply questionable manners. But again and again, when scientists observe what actually happens out there in the real ocean, a different ruler keeps turning up. A black and white shape, a clean dorsal fin, a pod moving with the kind of confidence that suggests not just strength, but certainty. Orcas do not blunder into the sea and hope for the best. They arrive like they have read the schedule, check the exits, and already know what everyone else is going to do. And that, perhaps, is the part that unsettles everything around them. There are plenty of predators in nature, but not many that seem to combine speed, teamwork, memory, communication, curiosity, strength, and a frankly unreasonable level of competence all in one body. Orcas are not simply dangerous. They are organised. They are adaptable. They are clever in ways that make other animals unpredictable around them. And if you are something living in the ocean, unpredictability is already bad enough. Intelligent unpredictability is worse. It is a strange thing to say that an entire ocean might be terrified of one animal. The ocean is, after all, absurdly large. It stretches across the globe, spills into trenches deeper than mountains at all, and contains enough corners and shadows and cold dark miles to make almost any creature feel small. But then there are the orcas, moving across those miles with ease, turning up in icy seas, temperate waters, coastal zones, open ocean, and even river mouths from time to time, as though no one ever explained to them that most creatures are supposed to pick a lane and stay in it. They are at home in places where other hunters specialise. They do not seem especially interested in respecting anyone else's title. If you have ever seen an orca in motion, even on a screen, you know there is something immediately striking about it. The colouring is bold, almost theatrical. Black back, white underside, bright eye patch, a body built not for clumsy power but for exact control. There is no wasted look to an orca. It does not appear stitched together by accident. It looks finished. Like a machine designed by evolution, after a very long series of revisions, each one improving the handling, the speed, the power, and perhaps most importantly, the brain behind the wheel. That brain matters more than people often realise. Many predators rely on instinct with a small margin for improvisation. Orcas do something more troubling. They learn, they teach, they pass techniques through families and pods. One group might know how to wash seals off ice floes. Another might know how to stun fish into tight bait balls. Another might know how to target the most vulnerable parts of much larger animals. Some populations specialise so clearly that scientists describe them almost like separate cultures, which means the fear surrounding orcas is not just fear of sharp teeth, though they certainly have those. It is fear of an animal that can decide, coordinate, adapt, and remember. That alone would be enough to earn a great deal of nervous respect. But orcas take the matter further because they do not seem content hunting only one kind of prey. They eat fish, seals, sea lions, penguins, dolphins, porpoises, rays, sharks, squid, and in some cases even whales far larger than themselves. They are not the kind of predator that becomes highly specialised and fragile if one food source changes. They are the kind that look at the menu, look at the season, look at the opportunity, and proceed accordingly. That is not comforting news if you happen to be something with fins, and then there is the social side of it. A solitary predator can be frightening. A coordinated predator is something else altogether. Orcas often move in pods, communicating with one another, working together, timing movements, adjusting positions, surrounding prey, and sometimes performing hunting strategies so deliberate they look almost choreographed. There is a difference between being chased by a fast animal and being managed by a group that seems to understand angles, panic, fatigue, and escape routes. One is a threat, the other is a system. Now, to be fair, the ocean is not literally a place where every creature is constantly quivering at the thought of orcas. Nature is not a cartoon, and marine life does not gather for dramatic group discussions about shared anxieties. But the patterns are hard to ignore. When orcas appear, other animals change their behaviour. Some flee, some fall silent, some abandon feeding grounds, some alter migration routes. Even formidable predators react in ways that suggest one clear fact. Orcas are not just another danger. They are the danger that other dangers try to avoid. That includes the great white shark, which is rather humbling if you have built your reputation around being the ocean's most intimidating smile. Great whites are large, efficient, and famous for good reason. But in areas where orcas begin targeting them, white sharks may disappear for weeks or even longer. Not because someone posted a stern warning sign underwater, but because survival tends to encourage very clear decision-making. If the local waters suddenly include a hunter that can kill you, remove your liver with awful efficiency and perhaps do it in a coordinated team effort, then relocating starts to look less like cowardice and more like excellent planning. And that is one of the reasons this topic is so fascinating. Orcas do not dominate through simple size alone. Plenty of animals in the sea are bigger. Blue whales are much larger, sperm whales are larger, whale sharks are larger. Even some sharks can make a respectable case for themselves in the dimension department. But size is not the whole story. The ocean does not run on a simple rule, where the largest thing automatically wins. It runs on speed, perception, endurance, surprise, coordination, and strategy. In that world, orcas are not merely strong, they're alarmingly complete. There is also something about them that stirs a very old kind of unease in people. Sharks frighten us because they are sharp and sudden. Deep-sea creatures frighten us because they are strange. Orcas do something a bit different. They frighten us because they seem aware. Not in a human way, of course, and not in some mystical sense, but in a concrete biological behavioural sense. They notice, they solve problems, they play, they investigate, they seem capable of trying things out. And once you realise that an apex predator is not simply reacting but thinking, the whole picture changes a little. It helps to remember that fear in nature is not usually dramatic, it is practical. A seal does not need a philosophy of dread. It only needs to know that certain shapes, sounds and movements mean death may be arriving early today. Fish schools do not need to hold tiny emergency meetings. They simply tighten, turn, bolt, and try not to become lunch. Evolution handles the rest. Over time, animals that respond well to danger survive, and those responses become written into behaviour. So when marine animals react strongly to orcas, we are seeing the result of repeated lessons taught by the sea in its usual unsentimental style. And the sea has had plenty of time to teach those lessons. Orcas have been around for a long while, and over that time they have spread into nearly every ocean on Earth. Arctic waters, Antarctic waters, the North Pacific, the North Atlantic, coasts, offshore zones, rich feeding grounds, cold currents, migratory routes. They are not some rare regional menace, they are global, which means the reputation they carry is not local gossip, it is widespread experience. Still, what makes them truly remarkable is that for all their power, they are not mindless destroyers. They are selective, they have preferences. Different groups eat different things, different pods use different sounds, different family lines pass down different ways of living. Scientists have observed patterns so consistent that the word culture becomes difficult to avoid, and that is an unusual word to use around a predator, yet it fits. Orcas do not just inherit instincts, they inherit habits, hunting methods, vocal traditions and social structure. That means each pod is not simply a cluster of animals, it is a functioning society, one built around knowledge. Knowledge changes everything. A shark may be terrifying, but it does not usually teach its children a region-specific strategy for creating waves that knock prey into the water. An orca can. A shark may be a brilliant design for being a shark, and there is no insult in that. But an orca can switch tactics when the situation changes. It can read the behaviour of other animals. It can exploit weakness. It can act with patience. That combination creates a very different kind of pressure in the ecosystem. It also explains why so many marine species respond to the presence of orcas with immediate caution. To a smaller whale calf, an orca pod is not just a passing concern. To a sea lion on an exposed rock, it is not just a distant shape. To a shark hunting in its own familiar territory, it is not just competition. It is the arrival of something that does not fit neatly into one box. Something that can chase, ram, bite, corner, coordinate, and wait. Something that can turn intelligence into force with very little warning. Even humans, watching from a safe distance, often sense this combination instinctively. There is a reason footage of orcas tends to hold attention. People recognise the power, certainly, but they also notice the control. Orcas do not usually look frantic. They do not waste motion. Whether surfacing in smooth arcs or accelerating into a strike, they move like animals that are comfortable at the top. And confidence at the top of the food chain has a way of looking very different from panic lower down. Of course, none of this means orcas are villains. Nature does not really do villains. It does hunger, adaptation, opportunity and consequences. Orcas are not cruel in the human sense. They are successful in the biological one. That success can look brutal from the outside, especially when we see them hunt animals we find impressive or sympathetic. But the ocean is not structured around our preferences. It is structured around survival. Orcas simply happen to be exceptionally good at it. There is something almost unfair about how many advantages they carry at once. They are large but still fast, powerful but also agile, social but also disciplined, intelligent without becoming hesitant, curious without losing focus. They can thrive in cold water, hunt in groups, navigate long distances, communicate clearly within their social networks, and take down prey that by all ordinary expectations should be too risky or too large. If you were designing an animal specifically to make the rest of the marine world nervous, you would struggle not to reinvent the orca. And perhaps that is why the phrase killer whale has held on so stubbornly in the public imagination, even if the animal is technically the largest member of the dolphin family. The name feels dramatic, maybe even unfair in some settings, but it captures how strongly these animals register on our minds. They do not come across as vague background wildlife. They come across as presence. Once they enter the frame belongs to them. So tonight, as we move gently through this story, we are going to look at why that is. Not in the exaggerated way of sea monster tales or nervous myths, but in the real biological, ecological and behavioural sense. We are going to look at what makes orcas so effective, why other marine animals respond to them the way they do, how they hunt, what they learn, what they teach, and why even some of the most capable predators in the ocean seem to make themselves scarce when orcas arrive. But before we go farther into these cold waters and black fins and quick decisions, let me ask you something small and fitting for the evening. Where are you listening from tonight, and what time is it in your corner of the world? There is something oddly nice about thinking of all of us scattered across different places, all arriving here to talk about an animal that itself crosses oceans with no regard for passports, calendars, or anyone else's travel plans. And if you find this soothing, interesting, or simply a pleasant way to settle your mind at the end of the day, I would be very glad if you liked the video and subscribed. It helps this quiet little corner reach more people who might enjoy drifting off with science, nature, and the occasional deeply overqualified predator. Now then, let us ease a little deeper into the water, because the first thing to understand about the fear surrounding orcas is that it is not based on one dramatic ability. It is based on a stack of them. An animal can be fast, and that is dangerous. It can be strong, and that is dangerous. It can have good senses, sharp teeth, stamina, or social support, and all of those are dangerous too. Orcas have the unsettling habit of collecting advantages the way some people collect kitchen gadgets, one after another, until you are left wondering whether any of this was really necessary. Take their bodies, for a start. An adult orca is not a delicate thing. It is a heavy, muscular marine mammal built to generate force quickly. The tail alone can drive bursts of speed that smaller prey have little hope of matching for long. The jaws are lined with large conical teeth designed not for dainty nibbling but for gripping and tearing. The body shape reduces drag and allows sharp turns. The dorsal fin, especially in adult males, rises like a dark flag that advertises exactly the sort of confidence you would expect from something with very few natural concerns. But raw anatomy still does not tell the whole story. Plenty of marine animals are physically impressive. What separates orcas is what they do with that physical power. They do not merely chase whatever appears and trust that momentum will sort things out. They assess. They position themselves. They learn which prey are worth the effort, which are vulnerable, and which techniques work best under specific conditions. They are not simply fast swimmers with teeth. They are fast swimmers with plans. That matters in water more than it would on land. The ocean is a three-dimensional environment with far fewer obvious barriers. Prey can dive, dart, scatter, and vanish. Light changes, visibility changes, depth changes. Distance can be hard to judge. In that kind of setting, cooperation becomes extremely valuable, and orcas are masters of it. A pod can spread out, herd prey, create confusion, block escape, and exploit panic. One individual might force movement while another waits for the mistake. This is not just predation. It is coordinated predation, which tends to shorten the odds for the prey in very unpleasant ways. Then there is the issue of endurance. Orcas are not tiny sprinters that burn out after one rush. They can travel enormous distances and sustain effort over time. If a hunt becomes a matter of pressure rather than instant capture, that pressure often favours the orca. A frightened animal may be able to burst away for a moment. Keeping that up while a group of intelligent predators stays on you is another matter entirely. The sea is wide, yes, but it is not always wide enough. And even when they are not hunting, orcas have a way of changing the atmosphere around them. The presence of a top predator often reshapes behaviour before any attack even occurs. Animals become more cautious, feeding changes, movement patterns shift, risk calculations happen fast. In that sense, fear is not merely a reaction to being attacked. It is a response to the possibility of being attacked. Orcas do not need to bite everything in sight to affect the ecosystem. Often, the knowledge that they could is enough. This is where the story begins to widen. Because once you start looking closely, you realise the fear of orcas is written not only in direct kills, but in avoidance, silence, and absence. In sharks that leave productive hunting grounds, in seals that crowd tighter to shore, in whales that defend calves with urgency whenever certain calls or fin shapes appear, in seabirds that react to surface commotion because they know what it may signal below. The ocean, in other words, has learned to read the arrival of an orca, and in the next stretch of this story, that is exactly where we are headed, into the practical side of this reputation, the reason so many animals seem to recognise these hunters before trouble even fully begins, and what it means to live in a world where one predator has become something close to a moving warning sign. What makes the orca so unnerving is not simply that it can kill. Plenty of animals can kill. In the sea, that is hardly unusual. The water is full of mouths, ambushes, toxins, stings, crushing pressures, and creatures that treat personal space as a mild suggestion. What sets the orca apart is that its reputation seems to travel ahead of it. Long before an actual attack happens, Other animals often react as though bad news has entered the neighbourhood. That is a very unusual kind of power. Most predators are dangerous only at close range. A fish does not spend its entire life thinking specifically about one barracuda several bays over. A seal may be alert for sharks in general, but it does not usually seem to respond as though a single species has somehow become a moving weather system. Orcas are different. When they appear, the reaction is often immediate and practical. Prey animals bunch together, flee to shallower water, haul out onto ice or rock if they can, or simply stop doing whatever relaxed thing they had been doing a moment before. Even large marine animals that would not ordinarily panic around other hunters tend to become very serious very quickly. That is part of why the phrase "every ocean knows them" feels so fitting. Orcas are not obscure specialists hidden in one remote region. They are found in every major ocean on Earth, from polar waters to temperate coasts to open sea. They cruise through places with very different temperatures, prey types and conditions, and somehow they manage to remain effective almost everywhere. Most predators become associated with a particular habitat. Orcas seem to treat habitat more like a suggestion. Cold water, rich coastal shelf, offshore hunting grounds, fjords, channels, ice edges, migratory routes, it is all workable. Give them food, room to move, and enough local knowledge, and they settle in as though they had always meant to be there. That wide range matters because it means their reputation has been built in many ecosystems, not just one. In the Antarctic, seals and penguins react to them. In the North Pacific, salmon, sea lions, porpoises, and even sharks may respond to their presence. In the North Atlantic, they are known to target fish and marine mammals with equal competence. Near parts of South America, they have developed hunting strategies that look so precise they border on rude. They do not just survive in different oceans, they establish themselves in them. There is also something unsettling about how familiar orcas seem with the lives of other animals. They often appear to know where prey will be, when it will move, how it will try to escape, and which members of a group are most vulnerable. This is not magic. It is experience, memory, and social learning. But to the prey animal, the difference is not especially comforting. Whether a hunter catches you through mystical sea powers or because it has spent generations refining the most efficient way to ruin your afternoon, the result is still broadly disappointing. Take seals, for instance. A seal in the water is not helpless. It is fast, agile, and adapted to a life spent avoiding being eaten. It already lives with sharks, rough seas, and the sort of constant background risk that makes a calm nap on land look like a luxury resort. Yet in places where orcas hunt seals regularly, those seals behave with obvious caution. They stay close to refuge when they can. They scan. They react quickly to disturbances at the surface. That is because orcas are not merely stronger than they are. Orcas are good at turning the seal's own environment against it. Some pods create waves to wash seals from ice flows. Others force them into open water where escape options narrow. Some simply outmaneuver them through coordinated pursuit. It is one thing to avoid a lone threat. It is another to be confronted by several hunters that can anticipate your route, match your speed, and use teamwork without getting in each other's way. Even from a distance, it becomes clear why the local seal population would prefer the day to proceed without any black dorsal fins appearing on the horizon. Sea lions know much the same thing, and sea lions are not timid animals. They are loud, strong, and in some cases deeply convinced that every rock belongs to them personally, but confidence on land does not solve much when danger approaches from below. Orcas have been observed targeting sea lions with a level of control that shows clear familiarity with the job. A panicked sea lion might bolt, twist, dive, and surge for shore, yet the orcas pursuing it often look almost calm by comparison. They know the terrain, they know the timing, they know that exhaustion is part of the process. Fish are another matter, because at first glance it may seem odd that such a large predator would bother with comparatively small prey when it can hunt mammals. But this is one of the reasons the ocean knows orcas so well. They do not insist on one identity. Some populations focus heavily on fish, especially salmon or herring, and they do so with methods that reveal just how much coordination exists inside a pod. They herd schools into dense formations, they slap with their tails to stun prey, they take turns, they position themselves so effectively that the fish are not simply fleeing a mouth, they are being shaped into a meal. That flexibility gives orcas a wider ecological reach than many apex predators. A hunter that eats only one category of prey may be dreaded by that prey, and largely irrelevant to everything else. Orcas are relevant to almost everything else. Fish know them, seals know them, dolphins know them, porpoises know them, sharks know them, whales know them. If you live in the sea and are roughly the right size or the wrong size, or carrying the wrong amount of blubber, the wrong amount of liver, or a calf that cannot quite keep up yet, there is a reasonable chance orcas fit somewhere into your risk calculations. And then there are the sharks. This is where the reputation of the orca becomes especially interesting, because sharks are not usually cast in the role of nervous evacuees. The great white in particular has enjoyed a long career as the animal people mention whenever they want a conversation about the ocean to become less relaxing. Large, efficient, heavily armed, and not especially in need of public relations help, the great white has every appearance of an apex predator that expects others to make way, and then the orcas arrive. In areas where orcas have been observed hunting white sharks, the response from the sharks can be striking. They leave, sometimes quickly, sometimes for extended periods. That is not the behaviour of an animal dealing with mild inconvenience. That is the behaviour of an animal receiving a very clear message. White sharks are powerful, solitary hunters, but orcas bring a different set of tools. They are social, coordinated, highly intelligent, and in some cases apparently able to disable sharks with efficient targeting. For a shark, that changes the equation dramatically. Suddenly the familiar hunting ground is no longer a place where you are the main concern. It is a place where you might become the concern. Even more remarkable is the speed with which this can alter local behaviour. The mere appearance of orcas in some shark-rich areas has been followed by white sharks vanishing from the region. That tells us something important. Fear in nature does not require repeated committee meetings. Once a threat is recognised as serious enough, behaviour changes at once. The ocean is not sentimental about second chances. Large whales respond too, particularly when calves are involved. A full-grown whale may be enormous, and one can easily look at an adult humpback or grey whale and assume that size alone would discourage trouble. Sometimes it does, sometimes it merely changes the method. Orcas have been known to target calves or weakened individuals, and when they do, the defensive behaviour of adult whales becomes intense. Mothers position themselves carefully. Escorts may stay close. Adults may lash with their tails, charge, roll, or try to place their bodies between the pod and the calf. It is worth pausing on that. These are not timid animals. These are some of the largest creatures on the planet, reacting with urgency because the predator approaching them is one they recognise as credible. That recognition says a great deal. An animal does not invest that kind of energy in defence unless the threat is real. The fact that huge whales sometimes respond to orcas with immediate protective behaviour is one more sign that the orca's reputation is not exaggerated folklore. It is earned. Dolphins and porpoises know them too, which adds an extra layer of discomfort because orcas are themselves members of the dolphin family. There is something almost bureaucratically cruel about being pursued by a relative who took the family resemblance and then added mass, teamwork, and a stronger interest in tactical problem solving. Smaller cetaceans may flee, cluster, or alter direction sharply when orcas approach. Some species are potential prey, others may simply be avoiding a risky interaction. Either way, the caution is there. This broad recognition across species is one reason orcas feel so dominant. They do not occupy a single simple role. They are not merely fish eaters or mammal hunters or scavengers of opportunity. They are all of these in different places in different combinations depending on the culture and diet of the pod. That means the fear surrounding them is not built on one story repeated over and over. It is built on many stories happening in different corners of the sea all pointing to the same conclusion. When orcas show up, you pay attention. That global familiarity also changes the way humans encounter them. Sailors, fishers, coastal communities, whale watchers, researchers, and people who spend enough time near the sea tend to recognize the visual signature immediately. The tall dorsal fin, the black back, the white flash. Even from a distance, they announce themselves clearly. It is an efficient design, and perhaps not entirely considerate to the nerves of everything around them. There is no soft, anonymous arrival. When an orca surfaces, it tends to look exactly like what it is. And unlike many feared animals, orcas do not seem frantic when they move. That contributes to the effect. Fast, desperate predators can be frightening, but they also look as though they're working hard for the outcome. Orcas often do not. They glide, arc, surface, and reposition with a kind of control that makes them look less like animals improvising and more like animals executing. Even when they burst into speed, the motion seems purposeful rather than chaotic. It gives the impression of a hunter that is not testing possibilities but selecting them. That impression is reinforced by how much they rely on the pod. Social hunting is not unique to orcas, of course. Wolves do it. Lions do it. Some fish do it. But in the ocean, where movement is fluid and visibility can be poor, successful social hunting requires serious coordination. An orcapod may spread prey, gather it, isolate it, or exhaust it. Individuals may take roles that appear distinct. One pressures, one blocks, one waits, one strikes. To the prey, it must feel less like escaping a single attacker and more like trying to negotiate with a group project that has already decided your fate. The pod structure also means knowledge does not die with one individual. If a particularly effective hunting technique is discovered, it can be taught. If a seasonal pattern becomes familiar, it can be remembered. If a dangerous prey item requires caution, that caution can be built into the group's behaviour. Over time, this turns orca populations into collections of shared experience. They are not simply born dangerous, they become locally refined versions of dangerous. A shark can inherit good instincts, an orca can inherit a curriculum, and that curriculum matters because prey animals are not responding only to what orcas are in theory. They are responding to what local orcas actually do. A seal population living near wave-washing orcas will learn a different set of risks than fish-facing tail-slapping specialists or sharks encountering liver-targeting hunters. The fear is specific. It is grounded in repeated local outcomes. That makes it stronger, because nature tends to respect the lessons that arrive consistently. There is another reason the ocean seems to know orcas so well. They are visible. A deep-sea predator may be horrifying in principle, but if it spends most of its life in darkness several thousand meters down, its influence is not felt broadly by surface communities. Orcas operate in parts of the sea where many animals live, feed, migrate, surface, rest, and raise young. They are not hidden specialists from inaccessible trenches. They move through the main traffic lanes of marine life. They are seen, they are heard, they are encountered. That contact creates memory. Animals do not need human-style storytelling to build expectation. They only need repeated patterns. If a certain call, silhouette, or surfacing rhythm has often been followed by chaos, then bodies begin to respond before minds have time for anything resembling reflection. Tighten, dive, flee, gather the calf, leave the area, stop feeding. Survival does not require eloquence. There is also the matter of sound. The ocean is an acoustic world. Vision matters, but sound often carries farther and faster as useful information. Orcas are vocal animals, though not all groups sound the same or use calls the same way. Many marine species live in a world where noise can mean information, opportunity, competition, or danger. If you are an animal underwater and a known predator is not only visually recognizable but acoustically active, then the predator's presence may reach you before the body does. That makes avoidance both more possible and, for prey, more urgent. In some ways, this makes orcas resemble large terrestrial predators with long-established reputations. On land, many animals know what wolves mean. Many know what lions mean. They do not need formal introduction. The shape, smell, movement, and sound are enough. Orcas occupy a similar place in the sea, but with the added advantage of living in an environment where prey often has fewer stable refuges. There are rocks, ice, shallow zones, coastline and numbers, yes, but there are no trees to climb, few doors to close, and very little sympathy. That is why the reputation extends beyond prey and into competitors. When a top predator causes other top predators to shift their behaviour, that is not ordinary. It means the hierarchy is not flat. The sea contains levels even among the hunters, and orcas tend to operate very near the top of those levels. Not always unchecked, not magically invincible, but influential enough that other formidable animals often decide discretion is the better part of not being disemboweled. Even humans have spent centuries noticing this. Long before modern marine biology described ecotypes, prey specialization, and vocal traditions, people who live near the sea recognized orcas as powerful and unusual. Some cultures feared them, some respected them, some regarded them with a kind of cautious admiration. That reaction makes sense. When an animal becomes known across vast regions, not merely as large but as effective, stories gather around it. Reputation follows performance very efficiently. What is so striking, though, is that the reputation survives scrutiny. Once scientists began studying orcas closely, the animal did not become less impressive. It became more so. The closer the observation, the more detailed the picture of control, cooperation, specialization, and adaptability became. Very often, mystery shrinks under research. With orcas, the opposite happened. The facts turned out to be at least as interesting as the myths, and considerably worse for anything made of meat and blubber. So when we say the hunter every ocean knows, that is not just dramatic wording. It is a practical description of a predator with nearly global range, broad diet, strong social learning, and a habit of producing immediate behavioural changes in the animals around it. Orcas are not known because they are loudest, largest, or most common. They are known because encounter after encounter has taught the sea the same lesson. When these hunters arrive, ordinary rules become less reliable, and that lesson becomes even clearer once you look closely at the physical design that makes all this possible, because reputation alone does not chase down seals, scatter sharks, and pressure whales. Something has to carry that intelligence through the water, power those sudden turns, drive the bursts of speed, and back every clever tactic with force. In the next part of this story, that is where the focus shifts, from the widespread recognition of the orca to the body that makes so much of that recognition entirely justified. What gives the orca its edge is not one dramatic feature, but the way everything about the animal seems to serve the same job. The body, the senses, the coloration, the swimming style, the breathing pattern, the social structure, even the way different populations use sound, all of it points toward pursuit. Plenty of marine animals are strong, plenty are fast, a few are clever. Orcas are built in a way that stacks those qualities together until the result feels less like one adaptation and more like a complete hunting package. That is why they do not simply look impressive when they move through the water. They look fitted to it. Start with the basic frame. An orca is the largest member of the dolphin family, and adult males can reach lengths around 9 meters or more, with the largest recorded male approaching 9.8 meters and 10,000 kilograms. Noah notes that adult males also develop disproportionately larger pectoral flippers, dorsal fins, tail flukes, and overall girth than females. So even before you get into behaviour, you're looking at an animal that combines the agility associated with dolphins and the mass associated with something much more difficult to ignore. It is not shaped like a drifting giant that survives by sheer bulk. It is shaped like a heavyweight that never stopped training. Then there is the outline itself. Orcas are mostly black on top with white undersides, white patches near the eyes, and a grey or white saddle patch behind the dorsal fin. That colouring is not decorative. NOAA's ocean. Today's description points out that the body is counter-shaded, with the dark back blending with the darker ocean when seen from above, and the light underside blending with brighter water when seen from below. In practical terms, this means the animal's shape is harder to read, until the distance is already uncomfortably small. It is not in visibility, of course. A 6 metre to 9 metre predator does not vanish like a coin in carpet. But in water, where light is uneven and the eye has less time to judge accurately, that contrast helps delay recognition. For prey, a delayed recognition problem is rarely a welcome one. The same economy shows up in the body plan behind the dorsal fin. Ocean Today describes the peduncle, the muscular section connecting the body to the flukes, as the main engine room of the animal. Longitudinal muscles in the back and caudal peduncle drive the flukes up and down, generating thrust through powerful vertical strokes. The dorsal fin works like a keel, helping stabilize movement, while the pectoral fins steer and assist with stopping. That sounds almost mechanical when you list it like that, but perhaps that is the point. The orca does not swim by accident. It is assembled for control. It can hold a line, shift direction, accelerate suddenly, and still keep enough balance to operate in close coordination with other whales beside it. In a chase, precision matters nearly as much as speed, and the orca has both. Speed, importantly, is there when needed. A marine mammal fact sheet from the Alliance of Marine Mammal Parks and Aquariums notes that killer whales can reach about 45 kilometers per hour, though only in short bursts, while cruising much more slowly for long periods. National Geographic also notes that wild orcas are adapted to swim up to 40 miles a day and dive 100 to 500 feet several times daily. This matters because a successful hunter is not merely something that can sprint. It also has to search, patrol, reposition, and keep going when a meal does not immediately cooperate. Orcas are not built as one-use missiles. They are built for repeated effort, which means prey has to worry not only about the first rush, but about what happens after the first rush fails. There is another useful detail in those diving habits. Orcas are not the deepest divers among marine mammals, and in some ways that is revealing. They do not need to win every category to dominate the categories that matter to their usual prey. The same fact sheet notes that resident killer whales often spend most of their time in the upper part of the water column, with many dives staying under 20 meters, while National Geographic describes repeated dives of 100 to 500 feet as a routine part of daily life. In other words, the orca is not a specialist built to vanish into the abyss for heroic lengths of time. It is built for the busy zones of the ocean, the places where fish school, seals surface, porpoises travel, calves breathe, and many animals must repeatedly return to air. That gives the chase a very practical shape. Orcas hunt where the traffic is. Breathing also plays into that. Orcas are conscious breathers, which means they must surface deliberately to breathe through the blowhole, rather than breathing automatically the way humans do. At first, this might sound like an inconvenience, but in a hunter that lives near the surface and coordinates with a pod, it becomes part of a rhythm. Surface, scan, move, submerge, close distance, surface again. The chase is broken into practiced intervals, and the whole group can function inside that pattern. It is one reason orca movement often looks so composed from above. Even their breathing fits into the structure of the hunt rather than interrupting it. There is very little about an orca that appears wasted or poorly matched to the life it leads. The senses are just as important as the muscle. Noah states that killer whales rely on underwater sound to feed, communicate, and navigate. Ocean Today adds that they have excellent eyesight in and out of the water, a well-developed sense of hearing, and that sound is received through receptors associated with the jawbones, which act as a conduit to the ears. That means an orca is not limited to one information channel. It can see, hear and process echoes in an environment where visibility changes constantly, and prey may be above, below, behind, or hidden in murky water. It is difficult enough to escape a predator that is fast. It is harder still to escape one that can build a usable picture of you even when the sea is trying to keep secrets. For fish-eating populations, echolocation is a major part of the system. Ocean Today explains that orcas create high-frequency sound waves, focus them through the melon, project them into the water, and then read the returning echoes. NOAA has also highlighted how vessel noise can disrupt the use of sound in fish hunting killer whales, precisely because echolocation is so important to finding and capturing prey. That means the hunt is not only about swimming after something visible, it is also about probing the water ahead, locating fish, interpreting distance and shape, and adjusting movement before the prey even fully knows where the pressure is coming from. For a schooling fish, that turns the ocean from open space into a place that has already been measured. But one of the cleverest features of all is that not every orca population uses sound the same way. NOAA explains that killer whale diet is shaped largely by culture, with some ecotypes focusing on fish and others, like Big's killer whales, focusing mainly on marine mammals. Research archived by NOAA notes that mammal-eating killer whales do not rely on echolocation for prey detection in the same way, and more recent monitoring has shown that these mammal-hunting whales call far less frequently, likely to avoid warning prey with good underwater hearing. That is a remarkable adjustment. A fish eater can afford to be louder because fish do not process those calls the same way a seal or porpoise might. A mammal eater becomes quieter because silence itself becomes part of the weapon. The same species, then, can operate like a sonar user in one setting and a stealth hunter in another. That ability to change the acoustic style of the hunt says a great deal about how thoroughly orcas are built for pursuit. They are not chained to one rigid tactic by their anatomy. The body gives them options, and the social learning inside each population tells them which option fits the prey. Fish hunting groups can coordinate around sound-rich herding strategies. Mammal hunting groups can stay comparatively quiet and use stealth, timing, and sudden acceleration. The animal does not merely carry hardware, it carries a method, and the method can shift with the menu. That is a dangerous quality in any predator. In a large social predator that is already powerful enough to ram, bite, and drag, it becomes much more serious. Then there are the teeth, and here nature drops any remaining subtlety. Ocean Today says orcas usually have 40 to 56 interlocking conical teeth, each roughly 3 inches long, while the marine mammal fact sheet gives a similar range and notes that the teeth are designed not for chewing, but for grasping and tearing. That distinction matters. Orcas are not nibblers. They do not sit politely considering texture notes and seasoning. The teeth are for control. Grip the prey, hold it, tear it, break off what can be swallowed. If the chase is the opening act, the mouth is the part that closes the conversation. Once an orca has reached striking distance, the rest of the body's design has done exactly what it was meant to do. Even the famous dorsal fin deserves a little more respect than it usually gets. People tend to notice it because adult males can carry the tallest dorsal fin of any marine mammal, reaching up to 6 feet. But Ocean Today points out that the fin also acts like a keel, helping with stability. In other words, the dramatic look is attached to a practical function. It helps keep a large, fast-moving predator stable, while the rest of the body does the work below. That is very much the orca way. Something that looks theatrical turns out to be useful. Something that looks decorative turns out to help with control. Rather inconsiderate of evolution, really. It could have chosen either elegance or efficiency, and instead went with both. Heat management plays a role too. Ocean Today notes that the pectoral fins contain a network of veins involved in regulating body temperature. That matters in an animal found from Antarctic waters to tropical and subtropical seas. NOAA states clearly that killer whales occur in all oceans and are especially abundant in colder waters, though they also occur in warmer regions. A hunter with that sort of thermal flexibility is not tied to one narrow climate band. It can work in icy seas, cool coasts and warmer waters, adjusting not just behaviour but basic body function across a wide range. This is one reason the orca's reputation spreads so widely. The design is not local, it travels. And because it travels, the body has to support distance as well as violence. NOAE describes killer whales as widespread apex predators found in all oceans, living in pods and often using coordinated hunting strategies. National Geographic notes their daily drive to swim far and dive repeatedly, and whale and dolphin conservation reports that wild pods can cover more than 160 kilometres in a day. The orca, then, is not just built for the final seconds of the chase, it is built for the hours before that. The long patrol, the searching, the social cohesion, the movement between feeding opportunities, and the simple ability to remain ready. That endurance is easy to underestimate because the dramatic footage always focuses on the strike, but the strike sits on top of a body designed to work all day. What is especially striking is how little of this design works in isolation. Countershading helps close distance, speed helps exploit it. Steering helps manage angles, teeth finish the job, hearing and echolocation reveal where the opportunity is. Social coordination prevents waste. Silence, in some populations, keeps prey unaware. Endurance lets the pod keep pressure on. Put all of that together, and the chase stops being a random burst of violence and becomes a sequence. First, the body gets you there. Then the senses tell you what matters. Then the pod turns movement into control. That is why so many marine animals respond to orcas before actual contact occurs. They are not reacting to one threatening feature. They are reacting to a whole system that has been refined around catching things that do not want to be caught. And there is still one part of that system we have barely touched. In some predators, the body is the main story. With orcas, the body is only half the problem. The muscle, speed, camouflage, and teeth would already be enough to make them formidable, but what makes the design truly unsettling is what sits behind it. Memory, coordination, and learned technique. Because an orca is not simply built to chase, it is built to decide how the chase should happen, which is where this becomes even more interesting. Of course, none of that muscle means very much without the mind directing it. A fast body can still make poor decisions, sharp teeth can still miss, strength can still be wasted. What makes the orca so unnerving is that the power is paired with a brain built for handling a complicated social and sensory world. Killer whales live in stable social groups, rely heavily on underwater sound, use coordinated hunting strategies, and pass learned calls and hunting tactics through populations in ways researchers explicitly describe as cultural. That last detail matters more than it first appears. A predator that inherits reflexes is dangerous. A predator that can inherit experience is worse. Killer whales are highly social, and in many well-studied populations the core unit is the matriline, a family line centred on an older female and her descendants. NOAA describes pods as groups of maternally related individuals that stay closely affiliated, while EPA explains that sons and daughters remain with their mother for life, even after they have offspring of their own. So an orca does not grow up, disperse, and begin from scratch in the way many animals do. It grows up inside a long-running family system. That means information can accumulate. A young whale is not learning alone in open water through costly trial and error. It is born into a moving archive of habits, routes, calls, prey preferences, and social rules. That is one of the key reasons orcas feel so much more deliberate than many other marine predators. They are not simply acting as individuals. They are functioning inside a structure that preserves knowledge over time. NOAA notes that diet in killer whales is shaped not only by what is locally available, but primarily by the culture of each ecotype, including learned hunting tactics. In the northeastern Pacific, resident killer whales focus mainly on fish, especially salmon, while Big's killer whales focus mainly on marine mammals and squid. Those are not small differences. They are different ways of living, different ways of finding food, and different ways of teaching young whales what food even is. It is difficult to overstate how unusual that is in a predator of this size and range. This is where the brain behind the bite starts to show itself most clearly. The orca does not just know how to hunt, it knows what sort of hunt belongs to its family. A fish-eating group and a mammal-eating group may pass through the same broad region and still behave like communities with separate inherited traditions. That means the animal's intelligence is not just individual problem-solving in the moment, though there is certainly some of that. It is also long-term social learning, a kind of community memory that shapes behaviour before the young whale is ever old enough to lead anything. In practical terms, that creates predators that arrive already educated, which is terrible news for everything else. The brain itself gives some support to the impression that a great deal is going on inside the head of an orca. Comparative work summarised in PLOS Biology concluded that cetaceans have large and complex brains that support complex cognitive abilities. A later neuron count study reported that, despite lower neuron density than smaller dolphins, the killer whale has more grey matter and more cortical neurons than any mammal measured in that dataset, including humans. Brain size alone is never a magic shortcut to understanding intelligence, and no honest scientist would pretend otherwise, but those findings do matter. They tell us that the orca is not operating with a small, simple nervous system, crudely attached to a very expensive set of teeth. It is running a substantial amount of neural machinery. There is also the basic fact that cetacean life demands a lot from the brain in the first place. In water, a hunter must manage sound, movement, depth, social position, prey behaviour, surfacing intervals, navigation, and often coordination with several companions, all in an environment where visibility is inconsistent and targets may vanish below, above, or beyond the next shift of light. NOAA states that killer whales rely on underwater sound to feed, communicate, and navigate. That means a large part of the orca's life is not merely reacting to what it sees, it is constantly processing information that humans barely perceive at all. A predator with that kind of sensory workload does not benefit from being foolish. The ocean tends to punish foolishness rather efficiently, and yet orcas do not only process information, they appear to organise it socially. One of the most striking findings in killer whale research is the stability of their vocal traditions. NOAA says that pulsed calls are unique among populations, learned and culturally transmitted among individuals, helping keep the group together and functioning almost like family identifiers. A study on southern resident killer whales adds that discrete call repertoires form the basis of dialects shared across matrilines, pods and clans, and that these call structures have remained stable for decades, in some cases over 50 years. So when a pod moves through the sea, it is not just a cluster of hunters, it is a group carrying an acoustic identity that younger whales absorb and preserve. That kind of stability suggests a social world that is both structured and remembered. It also helps explain why orcas can coordinate so effectively. Coordination is not just a matter of being near one another. It depends on knowing who belongs with you, how they tend to move, how they signal, and what sort of response is expected in a given situation. In humans, we would call that familiarity. In orcas, it may be safer to call it practiced cohesion. Either way, the result is the same. A pod that has spent years, even decades, moving together becomes efficient in ways a temporary group never could. The hunt no longer has to be invented from nothing each time. Much of the work has already been built into the relationships. Older females seem to play an especially important role in that system. NOAA reports that resident killer whales travel and forage in larger groups, and follow the leadership of older females in matrilines. Another NOAA feature explains that pods are led by the oldest females through tightly knit matrilines, descended from one grandmother or mother. A well-known study summarised in PubMed found that post-reproductive female resident killer whales lead group movement in salmon foraging grounds, and that this leadership becomes especially pronounced in years when salmon are scarce. In other words, when life gets harder, the group appears to lean more heavily on experience. That is not mystical wisdom, it is ecological knowledge, and it can make the difference between finding food and not finding food. That same study is interesting for another reason. It connects the unusual long post-reproductive lifespan of female killer whales with the value of knowledge transfer. PubMed's summary notes that post-reproductive females may help kin through ecological knowledge, and a later PNAS study found that grandmothers improve the survival of grand-offspring, with especially strong effects when those grandmothers are no longer reproducing themselves. So the brain behind the bite is not just the quick decision made during an attack, it is also the stored map of good feeding grounds, the timing of salmon runs, the memory of lean years, and the judgment to lead younger relatives toward better odds. An orca family is not only protected by teeth at the front, it is protected by memory at the centre. There is something particularly unsettling about that if you happen to be the prey. It means you're not dealing only with hungry bodies, you're dealing with lineages that may have refined the same tactics across generations. That point shows up in field observations of specialised hunting behaviour. At Possession Island in the Crozet Archipelago, researchers observed intentional stranding, where killer whales deliberately slide onto beaches to seize elephant seals. The observations found that adult females performed most of the hunting strandings, and that calves were closely associated with adults during the behaviour. The paper even suggested that teaching by other pod members may occur according to who has the relevant skill. That is not instinct doing all the work. That is apprenticeship with very high stakes. Once you accept that, many things about orcas become easier to understand. The frightening variety of their hunting tactics is not the product of one giant whale waking up each morning with a new idea and too much confidence. It is the product of social learning layered on top of a capable brain and a flexible body. A group that has learned how to herd herring may become extremely efficient at it. A group that has learned how to stay quiet around marine mammals may preserve that stealth. A group that has learned how to use waves, beaches, or coordinated pursuit can hand those methods down. The bite is only the visible ending. The real weapon is the information that gets the pod to that ending again and again. The social side of hunting also affects how success is shared. NOAA research, comparing resident populations, found that female northern resident killer whales often catch prey and then share it with older independent offspring, especially adult sons. The same feature notes that southern residents show different patterns, likely reflecting environmental pressures and prey difficulty, but the broad point remains. Food in orca society is not always a simple matter of whoever catches it eats it. There can be family economics involved, and family economics in an apex predator is one of those phrases that somehow manages to sound both fascinating and mildly threatening. It means feeding can reinforce relationships, support offspring, and strengthen the social system that makes future hunts possible. That is another way the brain expresses itself. Intelligence in a predator is not only the dramatic moment of choosing left instead of right, it is also the ability to maintain the social conditions that make hunting reliable over the long term. A lone animal can be brilliant and still fail if it cannot sustain itself through hard seasons. A metroline with older leaders, learned calls, prey-sharing behaviour, and generations of accumulated local knowledge has a very different set of odds. One could say the orca does not merely solve the problem of catching prey, it solves the larger problem of making sure the next generation knows how to keep solving it too, which is a rather efficient way for a species to become widely feared. The use of sound reveals that same flexibility in a more immediate form. Fish hunting killer whales often depend heavily on echolocation and vocal coordination, but mammal hunting bigs killer whales are much quieter. NOAA notes that fish-eating populations use clicks, whistles, and calls for feeding and communication, while studies of mammal-eating killer whales indicate they call far less and appear to reduce overt sound while stalking prey that can hear well underwater. That difference is deeply telling. The orca is not simply a loud, socially busy animal that cannot help announcing itself. It can shift the whole acoustic style of the hunt depending on what is being pursued. If that is not a sign of intelligence shaping behaviour, it is difficult to know what would qualify. There is a temptation, when talking about animal intelligence, to either over-romanticize it or flatten it into something mechanical. Orcas resist both approaches. They are not tiny people in formal wear who happen to live in the sea, and they are not mindless feeding torpedoes with a few bonus calls attached. The research points to something more interesting and more useful. A large-brained, socially embedded predator whose cognition is tightly connected to ecology. Their intelligence is practical. It helps them find prey, coordinate with kin, preserve traditions, adapt techniques, and survive in different conditions. It does not need to resemble human intelligence in every detail to be formidable. It only needs to work very well for orcas, and clearly it does. That practical intelligence also explains why orcas can be so hard to categorize emotionally. People sense the social complexity and often want to project familiar motives onto it, but the actual picture is more grounded and in some ways more impressive. A matriarch leading the group during poor salmon years is not a sentimental story device. It is a documented pattern. Dialects lasting for decades are not cute ornaments. They are durable social markers. Calves shadowing skilled adults during risky hunting behaviours are not merely adorable side notes. They are part of the machinery by which a dangerous population stays dangerous. Once you see that clearly, the animal starts to feel less like a simple apex predator and more like an apex society. And perhaps that is the most important shift in perspective. We often talk about predators as if the critical unit is the individual body. With orcas, the truly powerful unit is often the family line. A single orca is impressive. A matrilineal carrying shared knowledge, stable relationships, group-specific calls, and decades of experience is something else entirely. The intelligence is distributed through the group as much as housed in one skull. One animal may remember a route, another may know a call variation, another may learn a maneuver from its mother, and over time the pod becomes more than the sum of its swimmers. For prey, this is a thoroughly unhelpful development. It means the thing chasing you may also be backed by a social system that has spent years getting better at the job. Even the conservation science around orcas reflects this reality. Agencies and researchers do not treat all killer whales as interchangeable because behaviour, social structure, and learned foraging patterns differ so much among populations. NOAA explicitly notes that residents and transients are distinguished more by behaviour and diet than by appearance. That is a subtle but important point. Two animals that look broadly similar on the outside can be running very different cultural programs on the inside. In one sense, the bite may look familiar. In another, the mind behind it may belong to a very specific regional tradition with its own rules, sounds, and methods. That level of specialization is one more reason the sea reacts to them with such seriousness. So when people say orcas are terrifying because they are smart, there is truth in that, but it needs sharpening. They are not frightening in the vague way that the word smart sometimes gets used, as if intelligence were just a flattering glow placed around an animal we happen to like. They are frightening because their intelligence appears in places that matter most to a hunter. In memory, in coordination, in restraint, in timing, in family leadership, in the ability to preserve successful methods and use them again. An orca does not need to think about philosophy to be formidable. It only needs to understand its world, its relatives, and its prey unusually well. By every sign we have, it does exactly that. And once a predator can think together, the next step almost takes care of itself, because a family that hunts, learns, and remembers also has to stay connected. It has to signal, coordinate, identify, warn, guide, and keep the whole moving network from dissolving into noise and distance, which is where the sea becomes less silent than it first seems, and where the story shifts from the mind itself to the sounds that let that mind move through a pod as if it were one living thing. If the body gives the orca its force, sound gives it reach. Long before teeth come into the picture, long before a tail beats harder or a prey animal fully understands what has entered the area. The pod is already connected by a world of clicks, whistles, and pulsed calls. That is one of the first things researchers point out when describing killer whales. They rely on underwater sound to feed, communicate, and navigate, and in the best studied populations, each pod carries its own distinctive set of calls, learned and passed along socially. Noé puts it very plainly. These sounds help maintain group cohesion and serve as family badges, which is a wonderfully calm phrase for something that, in practice, means the sea is full of moving families who can identify one another by voice, while hunting in a medium where vision is often unreliable. Water is not a visual world in the way land is. Light fades quickly, distance distorts shapes, and a body can vanish into green or grey or black with ridiculous efficiency. Sound behaves differently. It carries. It bends around obstacles. It reaches into water where eyes are of only limited use. So for an animal like the orca, sound is not a decorative extra. It is infrastructure. It is how the pod stays together, how individuals keep track of one another, how prey can be found, how social relationships are reinforced, and, in some ecotypes, how danger is either announced or carefully hidden. The result is that an orca pod is never just a set of bodies moving through the sea. It is also an acoustic network, a coordinated community stitched together by signals that are both practical and social. At the simplest level, killer whales produce three broad categories of sounds: clicks, whistles, and pulsed calls. NAA describes clicks as part of echolocation, the system whales use to locate prey and navigate underwater. Whistles and pulsed calls are more social in function, though the categories can overlap in complicated ways and actual behaviour is often richer than a neat textbook list suggests. Still, the broad picture matters. Clicks help an orca read the world. Calls help it stay connected to others in that world. And because those calls are learned rather than merely stamped out identically by instinct, the pod begins to resemble not just a hunting team, but something much closer to a speaking community. That idea becomes even more striking once you look at the stability of those vocal traditions. In resident killer whales of the northeastern Pacific, researchers have documented pod and clan level dialects that persist over decades. A long line of work, summarised in studies on dialect change and vocal clans, shows that matriline's share specific call types, pods share repertoires, and related pods form larger vocal clans. These are not random noises tossed into the water whenever somebody feels chatty. They are recurring, recognisable sound patterns associated with social identity. The pod does not merely travel together, it sounds together. In a very real sense, an orca can belong by voice. And this is where the phrase, language of the pod, starts to feel less like a poetic flourish and more like a practical description. No one honest should claim that orcas are speaking human language underwater with grammar lessons and stern punctuation, but they are clearly participating in complex learned vocal systems tied to family, affiliation, and behaviour. NOAA's description of calls as family badges is revealing for exactly that reason. A badge identifies, it marks belonging. It says who is who in a crowded place. For a species living in stable matrilines, often staying close to relatives for life, that kind of vocal identity is extremely useful. It allows a moving family to remain a family even when the water is dark, the distance opens, and everyone is surfacing at slightly different moments. There is also something deeply efficient about using sound this way in an animal that hunts socially. Coordination does not begin only when the prey is visible. It begins much earlier in how individuals maintain spacing, rejoin one another, manage movement, and share information about context. A pod that can stay acoustically connected has a tremendous advantage over a group that must rely only on line of sight. In other words, the language of the pod is not simply there to make the social world richer, though it certainly does that. It also makes the hunting world more manageable. It lets the group function as a group even when the ocean is doing its usual best to keep everything scattered and inconvenient. What makes the whole thing more impressive is that the sounds are not all used in the same way by all killer whales. One of the clearest differences appears between fish-eating resident killer whales and mammal-eating bigs, or transient killer whales. Residents are generally much more vocal, which makes sense in the context of fish hunting, where prey do not hear and respond to killer whale calls the way marine mammals can. Mammal-eating transients, by contrast, call significantly less frequently, and one study found that their vocal activity tends to increase after a successful attack rather than before it. The likely reason is beautifully practical and deeply unfair to seals. Marine mammal prey can hear killer whale calls and respond with anti-predator behaviour, so silence becomes part of the hunt. The pod does not merely have a language, it knows when to shut up. That detail alone tells you a great deal about orca intelligence and social control. Plenty of animals can make noise, fewer can make strategic choices about when vocalizing helps and when it becomes costly. In mammal hunting killer whales, the reduction in vocal behaviour is not just an absence, it is a behavioural adjustment shaped by prey that can eavesdrop. That makes the pod's acoustic life part of the larger predator-prey game. Fish hunting groups can afford a louder social and foraging style. Mammal hunting groups often become quieter until the danger of warning prey has passed. So even before the attack, the orca's language is already doing work, either by binding the group together or by stepping back just enough to preserve surprise. There is another layer here, and it is one of the reasons researchers have taken killer whale communication so seriously. The structure of calls does not just vary between broad ecotypes, it can also reflect kinship and social affiliation more finely within resident populations. One study found that the structure of stereotyped calls correlated with matriarch relatedness and social affiliation, suggesting that vocal similarity is not only a matter of the animals spending time together in some casual sense. The calls themselves seem to track social structure. That gives the pod soundscape an almost genealogical quality. The voice does not simply accompany the family, it carries traces of the family's relationships. If that sounds a little unnerving, it should. We're used to thinking of predators in terms of claws, teeth, speed, and muscle. We are less used to imagining them as socially coded beings whose voices mark ancestry and group membership. But that is precisely why orcas feel so different from many other top hunters. A shark can be an excellent shark without needing dialects. An orca seems to operate inside something much more layered. The social world is not an optional extra attached to the hunting apparatus. It is part of the hunting apparatus. The pod stays coherent because it is socially coherent, and its acoustic traditions help keep it that way. The evidence for vocal learning strengthens that picture considerably. One well-known study documented 2 juvenile killer whales separated from their natal pods and found clear signs of vocal production learning, including one young whale that mimicked California sea lion barks. That finding matters because it shows that killer whale vocal behaviour is not rigidly fixed. They can modify what they produce based on social and acoustic circumstances. Again, that does not mean they're composing tiny underwater operas or phoning in impressions for party entertainment, though the sea lion might reasonably file a complaint. It means their sound production is flexible enough to learn from exposure. A learned call system in a long-lived social predator is a very powerful thing. Vocal learning also helps explain how dialects can persist and change at the same time. They persist because young whales grow up hearing the calls of their family group and adopt them. They change because no cultural system is perfectly static forever. A long-term study of resident killer whales found that call types can diverge over periods of 12 to 13 years, with mechanisms of vocal differentiation consistent with social learning, rather than purely random drift. So the pod's language is both conservative and alive. It keeps enough continuity for identity to remain clear, while still shifting slowly through time. That is very much what you would expect from a real social tradition, rather than a set of hardwired noises with no room for history. And then there is the matter of combinations. because it would already be impressive enough if killer whales had stable repertoires of calls and whistles, but they do not stop there. Studies of resident killer whales and more recent work on Icelandic killer whales have found that whistle transitions and call combinations are often non-random. Specific combinations occur more often than chance would predict, and some are repeated across years, individuals and social clusters. Researchers are careful about what claims they make here, and so one should be careful too, but the broad point is still striking. Orca communication is not just a bag of isolated noises. There is sequencing, there are patterns, some sounds are more likely to follow others. That is not human syntax, but it is certainly more organised than simple noise-making. This matters because sequence allows more nuance. A single sound can identify or alert. A patterned series of sounds can do more. It can reflect context, social interaction, or a specific kind of coordination. In the study of whistle sequences in wild killer whales, the sequences were especially tied to close-range behavioural interactions, particularly among males. In the Icelandic study, mixed call combinations of 2 or 3 calls formed clusters that appeared repeatedly across years and groups. All of this suggests that the acoustic life of an orcapod is not merely a repetitive chorus humming in the background. It is active, structured, and sensitive to social circumstance. The whales are not simply together. They're interacting together in patterned ways. For a calf growing up inside that, the learning environment must be extraordinary. Imagine being born into a family where movement, hunting, and social belonging are all accompanied by a dense world of recognisable sound patterns. You do not need a schoolroom. The water is the schoolroom. You surface among relatives, travel with them, hear their calls, hear when they're quiet, hear what happens around prey, hear what happens after success, hear what belongs to your matriline and what belongs to other groups. Over years, the calf is not only becoming larger and stronger, it is being tuned into a living acoustic culture. That helps explain why orca societies retain so much continuity. Their traditions are not written down. They are sounded out again and again across generations. It also changes how one sees a pod in motion. From the surface, a pod may look serene, even minimal, a few dorsal fins, a measured pace, breath in white bursts, a dive, another surfacing. To us, it can seem almost quiet. Underwater, however, that same scene may involve a much richer exchange of clicks, whistles, and calls depending on the ecotype, the activity, and the prey. The visible calm hides a communicative layer. That hidden layer is one reason orcas can appear so coordinated with so little obvious fuss. The fuss is not absent. It is simply acoustic, and mostly not for us. That hidden world also helps explain why vessel noise can be such a serious problem, especially for fish-eating populations like the southern residents. NOAA has repeatedly highlighted that these whales depend on sound for feeding and communication, and that noise can interfere with echolocation and social calls. If your whole life is built partly through acoustics, then a louder ocean is not just annoying, it is disruptive in the most practical sense. It blurs the family badge, muddies the hunt, and interrupts the very system by which the pod keeps itself coherent. One could say the modern world has found a way to be rude even underwater. Still, even with that disruption, the resilience of these vocal traditions is remarkable. Dialects endure for decades. Clans remain identifiable. Pod repertoires continue to mark belonging. Mammal eaters remain comparatively quiet when stealth matters. Fish eaters continue to depend heavily on acoustic tools. That sort of persistence tells you that orca communication is not flimsy ornament. It is deeply built into how their societies function. Strip away the sound, and you do not merely make the whales quieter. You interfere with the social glue of the pod. There is something almost unsettlingly elegant about that. We began with an apex predator and found not just speed and teeth, but dialects, vocal learning, kin-linked call structure, strategic silence, and patterned combinations. The pod is not a crowd of hunters. It is a coordinated social unit whose members belong to one another through shared sound. Even their danger seems communal. One whale can bite, but the pod can communicate, and communication lets the danger travel through the group faster than any single body could manage alone. That is why the language of the pod matters so much. It is not a side note to the hunt. It is one of the things that makes the hunt possible at the scale orcas prefer. And once a family can keep itself together this well, once it can preserve identity, coordinate movement, and pass sound traditions down the line, the next step almost follows naturally. A pod that can remember one another by voice can also remember how to do things together, which prey to target, which route to take, when to stay loud, when to go silent, when to herd, when to rush, when to wait. In other words, the language does not end with communication. It feeds directly into the larger question of how orcas became so terrifyingly good at hunting so many different things. At first glance, the idea that orcas learned to hunt everything sounds like a dramatic exaggeration, the sort of line whispered by the ocean after a long week. But the science is not terribly far off. Killer whales are cosmopolitan apex predators, and researchers have documented them preying on more than 140 species, including bony fish, cartilaginous fish, squid, marine mammals, reptiles, and birds. At the same time, local populations often do not behave like broad generalists at all. They specialise. NOAA puts it very clearly. While diet depends in part on what is locally available, it is primarily determined by the culture of each ecotype, meaning learned hunting tactics pass through the group. So the real story is not that every individual orca knows every trick in the ocean. It is that the species, taken as a whole, has built an astonishing library of methods, and different pods inherit different volumes from that library. That distinction matters because it changes the orca from a simple opportunist into something much more interesting. A random predator may take many prey species simply because it is willing to try whatever fits in its mouth. Orcas do something more refined. One family line may focus on salmon with almost stubborn loyalty. Another may devote itself to marine mammals and squid. Other populations have specialised diets built around herring, toothfish, stingrays, sharks, seals or whale calves. Noah notes that in New Zealand some killer whales eat stingrays and sharks, while in Antarctic waters some eat minke whales, seals or Antarctic toothfish. So the phrase "learn to hunt everything" is really about distributed intelligence. The species covers an enormous menu because different populations keep perfecting different parts of it. The ocean did not hand them one universal rulebook. It handed them many local exams, and they seem to have kept most of the answers. That is one of the most unusual things about them. Most predators are shaped by ecology into a narrower role. Become excellent at chasing schooling fish, and you may not be ideal for dragging down a marine mammal. Become superb at ambushing seals, and herring may not be worth the fuss. Orcas somehow managed to support both extremes, not necessarily in one pod at once, but across the species through social learning. The techniques are not interchangeable little party tricks. They are practical solutions to very different prey problems. Fish scatter. Seals climb onto ice. Rays pin themselves to the bottom. Sharks come armed with teeth and rough skin. Whale calves have mothers the size of buses. Yet orcas have documented strategies for all of them. This is why their reputation feels so large. It is not just that they are dangerous. It is that danger in one region does not look exactly like danger in another, because the local pod may have spent generations becoming good at something very specific. Consider the fish specialist first, because fish are slippery in every sense of the word. A fish school is not a single target. It is 1,000 small decisions happening all at once, each fish trying not to be the one that becomes an educational example. In northern Norway, killer whales have been observed using what researchers call carousel feeding. They cooperatively herd herring into tight schools near the surface, then stun them with underwater tail slaps before eating the disoriented fish one by one. Underwater observations and kinematic analyses showed that these tail slaps are not random thrashing. They are targeted, mechanically effective strikes, often preceded by lunges that appear to direct the school rather than simply grab at it. In other words, the whales first shape the problem, then solve it. They do not rush into a cloud of fish and hope for the best. They turn the cloud into a manageable object. Even that method has layers. Researchers describing herring-feeding orcas in Norway have noted cooperative herding, the use of the sea surface as a barrier, and prey stunning that lets the whales pick off fish efficiently after the school has been compressed. Later work has shown that these whales can spend a great deal of time feeding, and more recent observations have even identified consistent geometrical attack patterns and division of labour in pairs hunting herring. That last part is particularly telling. It suggests that the technique is not merely everyone splash until lunch appears. Some whales seem to take on different roles, and long-standing partners may hunt together more effectively. So even in what looks like simple fish feeding, the learning is social, repeated, and fine-tuned. The method survives because it works, and it works because the whales do not keep reinventing it from scratch every winter. Now move from fish to seals, and the whole challenge changes. A seal is not a school. It sees better, hears better, reacts faster, and has a very strong personal preference for not becoming a demonstration piece in somebody else's hunting lesson. In Antarctic waters, killer whales have been observed performing one of their most famous techniques, wave washing. In a detailed account from the Antarctic Peninsula, researchers described a group manipulating the physical setting before the final strike. The whales reduced the size of the target flow, cleared surrounding ice, moved the flow into open water, and then generated coordinated breaking waves that washed a craybeater seal into the sea, where it was seized. The event involved repeated waves, side swimming to increase water displacement, and an attack sequence that looked very much like a task requiring planning and cooperation, rather than one burst of enthusiasm. It is difficult to watch that and not come away with a feeling that the seal was being worked on by a team that knew exactly what it was doing. That technique matters for a larger reason too. It shows that orcas do not only learn about prey, they learn about physics. Not in equations, of course, and not by filling tiny underwater chalkboards with stern calculations, but in the practical sense that they understand what certain body movements will do to water, ice, and the animal sitting on top of it. They can turn the environment into a weapon. A flow that seems like refuge becomes a lever. The sea surface becomes a tool. The open water around the ice becomes a trap. By the time the seal actually falls in, most of the real hunting has already happened. The prey has been isolated, destabilized, and stripped of the structure it was relying on. That is not just predation. It is method. Then there is intentional stranding, which sounds like a poor life choice until you remember who is doing it. In Patagonia, and later in other regions, killer whales have been observed deliberately surging onto shore or into the surf zone to seize pinniped prey hauled out near land. The classic reports from Patagonia documented intentional stranding while hunting near shore, and later work at the Crozet archipelago described adult females performing the behaviour principally, while calves closely associated with them. That Crozet study explicitly raised the possibility of apprenticeship and teaching. A young orca watching an adult slide onto a beach to grab a seal is not seeing a random stunt. It is seeing a very risky, very local method that must be learned with care if one wishes to avoid becoming a large and embarrassed object in shallow water. And somehow, in certain pods, the method persists, which means the lesson gets passed on. This is what makes the orca's hunting range so unusual. The species does not just occupy many environments, it acquires local answers to local prey problems and holds on to them. In one place, the problem is herring packed in deep, cold water. In another, it is a seal perched on unstable ice. Somewhere else, it's a sea lion pup in surf, a ray flattened against the seabed, or a shark with a liver rich enough to justify the trouble. The pod's traditions become a form of ecological fit. The whales are not simply built broadly enough to eat many things, they are socially equipped to become regionally effective at very different things. That is far more powerful than general appetite alone. Appetite gets you interested. Culture gets you results. Rays and sharks are another excellent example, because they are not easy prey in any ordinary sense. Rays can use the seabed, awkward body shape, and in some species dangerous spines. Sharks bring teeth, speed, and skin rough enough to wear down the teeth of predators that handle them often. Yet killer whales have repeatedly been documented preying on both. NOAA notes that some New Zealand killer whales eat stingrays and sharks. A 2023 report from the Gulf of California described different strategies used by orcas to prey on rays, and also summarised the global record of killer whale predation on many elasmobranch species, from makos and hammerheads to whale sharks and white sharks. The same paper notes that specialised hunting tactics are especially important when prey can cause injury or involve high foraging costs. That is a very polite way of saying that if you're going to attack something with a tail spine or a mouthful of blades, improvisation is not the ideal management plan. What is striking in the ray work from the Gulf of California is not just the prey list, but the variety of tactics. The authors describe stalking, charging, capturing from behind and from the side, tail-slapping behaviour, and interaction suggesting that not every kill ends in immediate consumption. They also note that older females may be involved in teaching these techniques to younger or less experienced whales. Again, the pattern repeats. A tricky prey type appears in a region. A pod develops a way of dealing with it. Younger whales watch and participate. Over time, the method becomes part of the local repertoire. It is a bit like discovering that your neighbourhood has a family recipe, except in this case, the recipe ends with a ray in pieces, and everyone else in the bay reconsidering their plans for the evening. Large whales take the story into even more serious territory. Killer whales do not typically go after full-grown healthy baleen whales casually, because even for them there are limits to how much unnecessary trouble makes sense. But attacks on calves and smaller vulnerable individuals are well documented. ANOAA repository summary of humpback interactions found that when mammal-eating killer whales approached humpbacks, they attacked 85% of the time and targeted only calves. Other research has described stopover areas where transient killer whales aggregate to prey on migrating grey whale calves, often using small groups to attack and attempting to drown their prey. So here again, the technique is fitted to the target. Orcas are not trying to overpower adult giants head-on for the fun of it. They focus on the age class and conditions that make the odds better. It is strategy, not bravado, and strategy tends to age well in predators. One could say that orcas learn to hunt everything by refusing to treat prey as interchangeable. Fish are not hunted like seals. Seals are not hunted like sharks. Rays are not hunted like whale calves. Even within similar prey categories, local conditions change the method. Herring near the surface in Norway invite cooperative herding and tail slaps. A seal on Antarctic ice invites wave generation and ice manipulation. A sea lion pup near a Patagonian beach invites intentional stranding. A shark may invite fast disabling attacks and selective feeding on the liver. The learning lies in matching prey, environment, and group skill. This is precisely what NOAA means when it says diet is primarily determined by culture, meaning learned hunting tactics. The prey list may be broad, but the actual methods are often quite narrow and carefully honed. And once a technique enters the culture of a pod, it can spread with surprising persistence. Calls are learned, diet traditions are learned, hunting strategies are learned. Matrilids stay together for years or life, which gives young whales abundant time to observe and practice. In the Crozet work on intentional stranding, the close association between calves and skilled adults strongly suggested social transmission. In broader reviews of killer whale specialization, culturally transmitted ecological specialization has even been proposed as a driver of major differences among killer whale populations. So we are not just talking about one smart animal figuring something out once. We're We're talking about traditions stable enough to shape ecology, behaviour, and perhaps even evolution over long spans of time. That is why orcas feel less like a single predator type and more like a collection of local hunting cultures all wearing the same black and white uniform. There is another point worth noticing. Learning to hunt everything does not mean becoming reckless. In fact, the opposite seems true. Orca tactics often reduce risk. Herding fish into dense balls is safer and more efficient than random lunging. Wave washing removes the prey's refuge before the grab. Targeting whale calves rather than adults is safer than trying to dominate a fully grown baleen whale every time. Silence in mammal hunting ecotypes reduces the chance of warning prey. Even shark predation often appears to focus on quick disabling moves and selective feeding. The pod is not collecting tricks because tricks are fun, though young whales probably do find parts of the learning process lively. It is collecting them because each one solves a problem while controlling costs. In ecological terms, that is exactly the sort of intelligence that survives. That practical intelligence also helps explain why different populations can look so different in the field. A fish-eating resident group may seem busy, vocal, and highly focused on schooling prey. A mammal-eating bigs group may appear quieter and more stealthy. A shark-eating or ray-hunting population may reveal entirely different body positioning and prey handling. Outsiders might call all of them orcas and leave it there, which is fair as a starting point. But the sea, which has to deal with the consequences, knows better. It knows that the same species can arrive carrying very different local expertise. The fin may look familiar, the tactic may not be, and for anything living underwater, that uncertainty is not comforting. It means you may recognise the hunter and still not know exactly which lesson your region's version has mastered. So this is how orcas learn to hunt everything, not by turning every individual into a universal expert, but by building a species-wide patchwork of specialists. One population writes the manual on herring, another develops a beach attack, another refines shark handling, another grows famous for wave-washing seals from ice. All of it is held together by social learning, long family bonds, repeated observation, and the sort of patience only a long-lived predator can afford. Over time, the accumulated result looks almost absurd from the outside. Wherever you go in the ocean, there seems to be some local group of orcas that has spent years becoming bad news for whatever happens to live there. And among all those lessons, one of the most unnerving may be the one that turned another apex predator into a temporary evacuation specialist. Because once killer whales showed they could hunt large sharks efficiently enough to make the survivors leave, the balance of fear in the sea became a little clearer, and a great white suddenly had very good reasons to be somewhere else. There is something deeply strange about watching one apex predator behave like prey. The great white shark is not built for nervous overthinking. It is built for ambush, power, and confidence. Its body is a long argument in favour of sudden violence. For decades, it carried the sort of reputation that made people lower their voices around the subject, as though speaking too loudly near the sea might somehow make one appear. And yet, in the last few decades, researchers working in places as far apart as California and South Africa have documented a pattern that keeps returning with uncomfortable clarity. When killer whales show up, white sharks often do not stay to discuss the matter. They leave, sometimes all at once, sometimes for weeks, sometimes for the rest of the season. That is not a small behavioural quirk. In the ecology of fear, leaving good hunting ground is expensive. A predator does not abandon productive water for the sake of melodrama. It abandons it because remaining has become worse. And that is what makes this whole story so revealing. We're not looking at a minor reshuffling between marine neighbours who happen to find each other tiresome. We are looking at a repeated pattern in which the presence of killer whales changes the behaviour of white sharks so strongly that the sharks vacate places they would normally use for feeding. In California, Long-term electronic tagging and visual survey data showed brief killer whale visits displacing white sharks from southeast Farallon Island and disrupting shark feeding behaviour for extended periods. In South Africa, direct observations of killer whales attacking white sharks were followed by immediate shark flight and prolonged local absence. The California evidence is especially useful because it is not built on one dramatic afternoon and a lot of rumour. It comes from years of data. At southeast Farallon Island, a major white shark foraging site near pinniped colonies, researchers tracked tagged sharks and compared their behaviour with the rare moments when killer whales appeared nearby. The results were difficult to dismiss. In multiple years, brief killer whale visits were followed by abrupt departure of white sharks and no return for the rest of the season. In the best documented 2009 event, killer whales remained at the island for just over 2.5 hours. 17 tagged white sharks had been present. After the killer whales arrived, detections dropped to 0 for the remainder of the season. 7 of those sharks later turned up nearly 90 kilometres south at Año Nuevo Island. That is not ordinary wandering. That is relocation with purpose. The same study found that the effects went beyond the sharks themselves. In years when killer whales appeared close to the island during or before peak shark abundance, observed white shark predation on pinnipeds dropped sharply by roughly 3.5 to 7-fold relative to the long-term average. In other words, the killer whales did not need to kill every shark in sight to alter the local food web. Their presence alone changed who hunted whom and where. That is one of the most unnerving things about top predators with strong risk effects. They do not merely consume, they rearrange. A short visit can create empty water, and empty water can echo through an ecosystem long after the dorsal fins are gone. There was even a historical clue before those tagging data made the pattern clearer. The Farallon study notes that in 1997, a white shark was killed and partially consumed by transient killer whales at the same site, with the liver taken, and shark observations declined sharply afterward. So the modern tracking work did not create a brand new mystery. It gave structure to one that had already shown itself. A white shark gets killed. The others vanish. The feeding pressure on seals drops. The site changes. By the time researchers could document the phenomenon in detail, the broad lesson had already been written in the water. Great whites, for all their power, do not treat killer whales as an inconvenience. They treat them as a reason to go elsewhere. Then South Africa added something even more vivid. In 2022, researchers directly observed killer whales preying on white sharks at Mossel Bay, giving one of the clearest windows yet into how these interactions can unfold in real time. The event involved a group of 5 killer whales. One of them was starboard, a male with a bent dorsal fin that had already been linked to earlier shark predation events in South Africa. Drone and helicopter footage captured the group interacting with multiple white sharks and provided the first confirmed filmed observation of killer whales killing a white shark there. The significance of that is hard to overstate. Earlier South African evidence had already pointed strongly in this direction through carcasses and shark disappearance. This time the hunt itself was seen. The details are almost annoyingly efficient. In one observed interaction, a killer whale pushed an estimated 3-metre white shark up from below, rolling it to the right side. In another sequence, large white sharks displayed evasive behaviour, circling tightly while killer whales followed at close range. At one point, what appeared to be a free-floating shark liver was photographed at the surface before being taken into a killer whale's mouth. The researchers concluded that at least 2, and possibly 3, white sharks were killed over roughly 71 minutes. They also noted that the behaviour matched what had been inferred earlier from carcasses with missing livers and torn pectoral regions. So even the famous liver targeting was no longer just a grim anatomical riddle washing ashore. The pattern was becoming directly visible. Yet the most fascinating part may not have been the kills themselves. It was what the surviving sharks did. According to the same study, beach-based observers reported white sharks fleeing the area in several directions just minutes before the predation, with some swimming into extremely shallow water less than 2 meters deep. It is worth pausing there for a moment. A great white shark entering unusually shallow water is not a casual whim. It is a sign that the ordinary logic of the animal's habitat use has been interrupted by something more urgent than comfort or hunting efficiency. That urgency, in this case, appears to have had black and white colouring and no interest in fairness. The flight did not end with a single panicked burst. The drone records from Mossel Bay are especially telling. Before the 16th of May predation event, drone surveys commonly recorded white sharks in the area, with an average of 4 sharks per flight and as many as 10 different sharks observed over 75 minutes on the day of the predation. During the 8 days after the event, only 1 shark was recorded, and that was on the following day. Commercial cage diving operations told the same story from a different angle. Before the predations, operators encountered an average of 3.3 individual sharks per trip. Afterward, they saw 0 white sharks for 45 days, with the first shark returning only on July 1st. The local water did not stop being shark habitat. It became, for a time, killer whale habitat, and that was enough. One tagged female white shark helps make the story even more concrete. She had been fitted with a satellite tag in Mossel Bay on the 25th of April, 2022. She remained in the area and was last detected there on the 14th of May, 2 days before the predation event. Her next detection came 400 kilometres east at Algoa Bay on the 25th of May. That is a remarkable shift in a short period, and while one should be careful not to turn one shark into a full documentary script all by herself, the movement fits the broader pattern very neatly. The issue was not simply that 1 or 2 sharks were unlucky. The issue was that local predation risk had changed, and white sharks behaved accordingly. This tells us something important about white sharks, and it is not an insult to them. Great whites are not foolish. They are not brave in the human sense, and they have no obligation to defend a patch of ocean out of principle. Their job is to survive long enough to feed, grow, and reproduce. If a larger, social, highly intelligent predator arrives with a proven ability to disable and disembowel your kind for an energy-rich liver, then leaving is not cowardice. It is excellent cost-benefit analysis. Nature is full of dead animals that mistook pride for strategy. The white sharks that leave are the ones making the sensible choice, and there is every reason for that choice to be sharp. The California study makes clear that killer whales and white sharks overlap strongly in distribution and trophic niche along the western North American coast. They use some of the same hunting grounds and exploit some of the same prey fields. The South African work adds that the killer whales observed there were not merely passing by in some unrelated business. They were hunting sharks directly. In California, even brief killer whale visits were enough to trigger long absences by white sharks. In South Africa, direct kills were followed by immediate and extended disappearance. Taken together, those findings suggest that white sharks are responding not to a vague rumour of danger, but to a threat with very real lethal potential. There is also something revealing about how selective the killer whales appear to be. The Farallon work notes that occasional consumption of the highly caloric liver of white sharks may provide energetic benefits. The South African observations and the later Frontiers paper on whale shark predation reinforce the broader pattern of killer whales targeting lipid-rich internal organs when hunting elasmobranch prey. This is not random biting, it is profitable anatomy. The liver of a large shark is energy-dense, and killer whales seem very aware of that. A predator that knows which part of you is worth the trouble is not merely strong, it is informed. That tends to make everyone nearby uneasy, including other predators. Now, one should be careful not to oversimplify the whole global picture. Researchers working in South Africa have noted that the broader decline and disappearance of white sharks from places like False Bay is not explained by one factor alone. A 2025 Frontier study on trophic cascades in False Bay states that the exact reason behind the loss of white sharks there remains unclear and points to multiple possible contributors, including lethal shark control programs and likely contribution from specialized shark-eating orcas documented elsewhere along the coastline. In False Bay, white shark abundance fell sharply after 2015, and white sharks disappeared from standardized surveys after mid-2018. But the paper is explicit that the drivers are complex, so it would be too simple to say killer whales single-handedly erased white sharks from every South African hotspot. The cleaner claim, and the one well supported by data, is that killer whales can trigger immediate shark flight locally and may contribute meaningfully to broader redistribution or decline in some systems. That distinction matters because it makes the story more credible, not less. Reality is rarely tidy enough to give us one villain, one victim, and one dramatic turning point, but localized flight responses are very real, and they are ecologically powerful. In California, brief killer whale visits redistributed shark foraging pressure from one seal colony to another. In South Africa, direct predation was followed by weeks of white shark absence in Mossel Bay. In False Bay, white shark disappearance coincided with increases in Cape fur seals and seven-gill sharks, and decreases in some prey further down the food web, producing what researchers described as empirical evidence of trophic cascade following the loss of white sharks. The day great whites started fleeing, then, is both a dramatic moment and a broader ecological pattern. The fleeing itself can happen quickly. The consequences can linger. And that may be the most unsettling part of all. When people imagine ocean terror, they usually imagine direct attack. Teeth, blood, a single violent event. But fear has another form in nature, quieter and in some ways more powerful. Fear changes routes. It changes feeding times. It changes whether an animal dares to approach a profitable place or decides to burn energy moving elsewhere. The Farallon study describes exactly this sort of risk effect among upper trophic level predators. The sharks that survive are still shaped by a danger they may never directly feel in their own flesh. The moment killer whales become possible, the calculation changes. This is not just predator versus predator, it is predator versus the memory of what another predator can do. It also rearranges the public imagination in a rather satisfying way. We spend so much time treating the great white as the final answer, the closing argument, the animal at the end of the sentence. Then along come killer whales to remind everyone that food webs are not written for our cinematic convenience. The apex can have an apex above it, or at least a highly persuasive visitor. A white shark may dominate many situations in its own right, but dominance is contextual. It depends on who else is in the water, how many of them there are, and what they have already learned about taking your kind apart. That is not a comforting realization for a shark, though for the rest of us it is scientifically delightful in a slightly uncharitable way. Even so, one should resist turning the white shark into a helpless victim in this story. It is still one of the sea's most formidable solitary hunters, and in many places it continues to occupy that role with impressive success. But this particular interaction exposes the limits of solitary power when it encounters social intelligence. A killer whale pod brings coordinated movement, shared information, and, in some populations, experience with elasmobrunch prey. A white shark brings speed, teeth, and one very good body. Under many conditions, that body is enough. Against a coordinated group of killer whales with a history of shark predation, it may not be. And when the sharks appear to know that before the attack is fully underway, the ecological message becomes impossible to miss. So yes, there really were days when great whites started fleeing. Not because the ocean suddenly became theatrical, but because repeated observations, tagging records, and direct predation events showed that these sharks respond to killer whales with abrupt departure and prolonged avoidance. California gave us the clean long-term pattern. South Africa gave us the close-up violence and the immediate aftermath. Together they revealed something the sea may have known for much longer than we did. A great white is terrifying right up until the wrong fin appears nearby. Then terror changes direction. And once even great whites decide that leaving is the wiser move, the question gets bigger very quickly. Because if a shark famous for making seals explode out of the water would rather evacuate than stay put, then what exactly does that say about the rest of the marine world, including the giants that are larger than orcas, but not necessarily safer when a pod has decided to press the issue? One of the easiest mistakes to make in the ocean is to assume that size settles everything. On land, we often think of bigness as the final argument. Be larger than the threat, and the threat becomes less troubling. In the sea, that logic does not always hold. Water changes how force is applied, how groups move, how attacks develop, and how quickly a vulnerable young animal can become separated from the body that was supposed to protect it. Orcas take full advantage of that. They do not need to be bigger than every whale in the ocean to be feared by them. They only need to be organised, persistent, and selective about when and how they attack. That is exactly what researchers have repeatedly documented. This is the point where the story becomes especially interesting, because large whales do not all respond to killer whales in the same way. Some fight back fiercely, some cluster around calves, some shift habitat use, some seem to rely on shallow water, escort behaviour, or acoustic quiet to reduce risk. The common thread is not helplessness, it is caution. Being giant does not mean being unworried. In many cases it simply means the rules of danger change. A full-grown baleen whale may be too costly to attack under ordinary conditions, but its calf is not. A healthy adult may fend off a pod under some circumstances, but that does not mean the pod cannot harass, injure, or keep probing for an opening. Size then becomes a negotiation rather than a guarantee. Humpback whales are a perfect example of this uneasy balance. They are massive, powerful, and surprisingly combative when killer whales are around, particularly when calves are involved. In a large review of 115 interactions between humpbacks and killer whales, humpbacks actually initiated the majority of interactions, and when mammal-eating killer whales approached humpbacks directly, they attacked 85% of the time and targeted only calves. That is a very revealing result. It tells us two things at once. First, adult humpbacks are not easy prey, and often respond aggressively enough to confront or mob killer whales. Second, orcas know perfectly well where the real opportunity lies, and that opportunity is the calf. The adults are not being ignored out of politeness, they are being managed while the smaller target is tested. That same humpback review is striking for another reason. It found that humpbacks often interfere when mammal-eating killer whales attack other species entirely, a behaviour the authors describe as mobbing in many cases. In other words, humpbacks do not just react when their own calves are threatened. They sometimes rush toward the sound of attacks involving seals, sea lions, grey whales, or other animals, apparently because the sound profile resembles the kind of event that would endanger a humpback calf. This is one of the clearest signs that killer whale predation pressure has shaped the behaviour of very large whales over time. A giant animal does not charge into a chaotic predation scene for no reason. It does so because, in evolutionary terms, failing to respond when calves are at risk has likely been a poor long-term strategy. The scars reinforce that story. Studies of humpback whales in the North Pacific have used photographs of flukes to assess how often whales carry toothache marks from killer whale attacks, and the results show substantial geographic variation in scarring, enough for researchers to argue that predation pressure may be a major force affecting behaviour and migration. In other words, attacks do not always end in death, but they happen often enough to leave the bodies of survivors marked in ways that researchers can measure across regions. A giant whale carrying those marks is a reminder that size can prevent the worst outcome without removing the threat itself. Survive often enough, and the evidence stays with you. Grey whales make the same point in a more direct and often harsher way. Along the Alaska Peninsula, researchers documented a stopover where transient killer whales gather during the northbound migration of grey whales, specifically to hunt calves and yearlings. The study described more than 150 transient killer whales aggregating annually in the area, with most observed predatory attacks focused on young grey whales. The attacks were typically carried out by groups of 3 to 4 killer whales that attempted to drown the calf, and the attacks were often abandoned quickly if the mother defended aggressively enough. That is a grim but important detail. A mother's defence can matter enormously, but the reason it has to matter is that the risk is both real and repeated. Orcas are not casually harassing grey whale calves in these waters. They are exploiting a predictable migration bottleneck. You can almost see the logic from both sides. For the killer whales, migrating grey whales create a seasonal opportunity. Calves are young, still learning, and moving through known routes. For the mothers, every kilometre is a balance between movement and defence. They have the size to resist, but they also have a calf that cannot. The consequence is a set of behaviours that look a great deal like strategic caution. Earlier reviews of grey whale attacks have described mothers and calves making long dives, barely exposing their blowholes at the surface in so-called snorkel behaviour, and travelling with escorts when possible. Those are not the habits of animals that feel untouchable. Those are the habits of giants who know exactly what sort of hunters may be nearby. Southern right whales offer another remarkably clear case of giants adjusting their lives around killer whale risk. Research from Patagonia reported that southern right whales altered their habitat use over decades, abandoning the area with the highest occurrence of orcas and shifting into adjacent bays. That is a major ecological decision for a large whale population, and it strongly suggests that predation pressure from killer whales can influence where even very large cetaceans choose to spend time. A whale does not relocate nursery use along a coastline because the scenery has gone stale. It does so because one area has become too dangerous, especially for calves. When giant animals change geography rather than gamble, that tells you the threat is both credible and costly. The same logic shows up in sound. A study of southern right whale mother-calf pairs in Western Australia found that these pairs use low output, infrequent calls, and maintain close physical proximity in ways that are thought to reduce the risk of alerting eavesdropping killer whales. The authors explicitly describe this as acoustic crypsis, essentially quiet behaviour that helps avoid broadcasting the location of a vulnerable newborn. There is something almost darkly practical about that. The sea is already difficult enough for a newborn calf, and now even the most basic act of keeping in touch with its mother has to be carefully managed so as not to invite the wrong audience. When giant whales lower their volume for fear of being overheard, the size argument has plainly failed. And then there is the fact that killer whales have now been documented killing and eating blue whales, the largest animals on Earth. The 2022 paper from Western Australia reported the first 3 records of killer whales killing and feeding on blue whales, ending a long-running debate over whether orcas could successfully bring down animals of that scale. One should still be careful here. The broader question of how often such attacks occur and under what specific conditions remains important. But the essential point is no longer hypothetical. Sheer enormity does not create automatic immunity. The largest body in the ocean can still become prey under the right circumstances when the attackers are numerous, coordinated and persistent. That is not something the public imagination used to grant easily, but the observations are now there. What this really means is that large whales tend not to treat killer whales as a binary problem of either we are safe or we are doomed. They treat them as a conditional danger. A healthy adult humpback may stand its ground, mob, lash with the tail, or position itself between the pod and the calf. A grey whale mother may defend fiercely enough to make the attack too expensive. A right whale mother-calf pair may move into shallower, acoustically noisy habitat and stay quiet. A population may shift where it prefers to calve or nurse. Those are not the responses of animals that believe size solves everything. Those are the responses of animals that know it solves only part of the problem. There is also a reason calves sit at the centre of so much of this story. Orcas are not reckless. They do not need to prove themselves by charging indiscriminately at every adult whale they meet. Their hunting behaviour around large whales tends to be selective, focused on the age class or condition that makes the risk worthwhile. The Humpback Interaction Review found that when mammal-eating killer whales approached humpbacks directly, the attacks targeted calves only. Grey whale work around the Alaska Peninsula likewise found calves and yearlings at the centre of most attacks. This is the same pattern we saw earlier with sharks and with different prey specialists in different regions. Orcas do not just hunt what exists, they hunt what can be taken efficiently enough to justify the effort. A giant mother may be too much trouble, her calf may not be. In a strange way, this makes large whales more impressive, not less. They are not living under an illusion of dominance, they are living inside a realistic system of defence. Humpbacks, in particular, seem to have turned direct confrontation into part of that system. The review of humpback interference with killer whales showed not only that humpbacks often approach attacks, but that many of these interactions fit the pattern of mobbing behaviour. The adults may use body positioning, flipper strikes, tail thrashing, and close escort of calves or other vulnerable whales. They are not passive giants drifting through danger with an expression of noble disappointment. They are active defenders who seem to understand that the best answer to killer whales is often to become as loud, awkward, and physically troublesome as possible. Still, even vigorous defence is its own kind of admission. You only mob a threat that matters. You only alter your routes, nursery grounds, calling behaviour, or escort patterns when natural selection has made the costs of ignoring that threat painfully clear. This is why the title of this section is really about distance in a broader sense. Not every giant literally swims away every time an orcapod appears. Some rush forward, some fight, some hold position. But even then, there is a distance being managed. Mothers keep calves closer, pairs stay in shallower water, calls get quieter, populations shift to bays with lower orca occurrence. The giants may not always flee, but they do live with a careful buffer around the possibility of orcas. And perhaps that is the most revealing part of all. Fear in the ocean is not always visible as panic. Sometimes it looks like habitat choice. Sometimes it looks like silence. Sometimes it looks like a mother placing her body between a calf and an incoming pod. Sometimes it looks like a humpback charging toward the sounds of an attack that is not even about her. Sometimes it looks like a giant species building a whole nursery strategy around not being easily detected. The distance, then, is not always kilometres. It can be behavioural. It can be acoustic. It can be spatial. It can be generational. Orcas shape all of those. This also helps correct a common misunderstanding. Saying that even giants keep their distance does not mean orcas casually dominate every large whale they encounter. The actual picture is more nuanced and in many ways more interesting. Adult large whales are formidable. Mothers can repel attacks. Escorts can help. Some pods of killer whales break off when defence becomes too costly, exactly as the grey whale work describes. But none of that weakens the central point. It strengthens it. If even very large whales need coordinated defence, shallow water tactics, quiet mother-calf communication, and sometimes broad habitat shifts to reduce killer whale risk, then the risk is clearly serious enough to shape their lives. That is what makes the orca's influence so remarkable. It does not need universal success to create universal caution. So when people imagine the ocean's giants as beyond fear, they are imagining a simpler world than the real one. The real world is full of trade-offs. Be huge, and you gain strength, endurance, and the ability to fight back. You also gain a calf that takes years of investment and becomes an obvious target. You gain broad migration routes that pass through bottlenecks where predators can gather. You gain the ability to thunder through the sea, but also the burden of being heard if you call too loudly. Orcas exploit those trade-offs with unsettling efficiency. That is why even giants behave as though black dorsal fins deserve immediate attention. They have learned, over generations, that size makes the fight harder, not impossible. And once that lesson settles in, the next layer of the story becomes harder to ignore, because what we are really looking at is not only predation, but anticipation. An ocean where calves stay quiet, sharks leave, and large whales alter behaviour before the bite ever comes, is an ocean shaped by fear as much as by feeding. That is where the water gets especially interesting, because the most powerful thing about orcas may not always be what they kill, but what their presence alone makes everyone else do. What makes orcas so powerful is not only what they kill, it is what they make everyone else do before the kill ever happens. That is a different kind of dominance, quieter and in some ways more complete. A bite is immediate, a chase is visible, but fear begins earlier than that. Fear starts when an animal changes direction, goes silent, stays closer to shore, bunches up with others, skips a feeding area, cuts a dive short, or moves its young somewhere less profitable but more survivable. In ecology, those are often called non-consumptive effects, meaning the predator is shaping the prey's life even when no one has actually been eaten yet. And with orcas, those effects can be enormous. They do not just remove animals from the sea. They alter routines, routes, group spacing, sound use, and habitat choice. In other words, their influence begins long before the teeth arrive, and by the time the teeth do arrive, much of the real work has already been done by anticipation. That matters because the ocean is built on routine. Animals survive by repeating what usually works. Fish gather where food is dependable. Seals haul out where access is easy and danger is manageable. Sharks patrol profitable corridors. Mothers bring calves through routes that have worked before. Deep-diving whales forage according to patterns that balance food, oxygen, and safety. The moment a predator can interrupt those patterns at scale, it starts reshaping the ecosystem without needing to be present every minute of the day. Orcas are especially good at this because they are mobile, intelligent, and socially coordinated. They can appear, hunt efficiently, and leave behind a memory strong enough to change what other animals do afterward. That memory is one of the most important things in the water. Nature does not require abstract dread. It only requires repeated consequences. If a black dorsal fin has often been followed by chaos, then the body learns first and the rest follows. White sharks provide one of the clearest examples of this invisible pressure. At southeast Farallon Island in California, researchers used long-term tagging and survey data to show that even brief killer whale visits displaced white sharks from a major feeding site for the rest of the season. In the best documented case, killer whales stayed just over 2.5 hours. 17 tagged white sharks had been present before the visit. Afterward, detections dropped to 0 for the remainder of the season, and several sharks were later detected almost 90 kilometers away at Año Nuevo Island. This did not simply change shark location, it reduced white shark predation on pinnipeds at the island by several-fold in those years, so the effect of the orcas rippled outward. The sharks left, the seals faced less shark pressure. The whole local arrangement shifted because one top predator had entered and made another top predator decide the area was no longer worth the risk. That is fear beneath the surface in a very literal sense. No mass slaughter was needed, a short visit was enough, and once fear starts rearranging one predator, it can keep travelling down the chain. A 2025 study from False Bay, South Africa, found evidence of a trophic cascade following the loss of white sharks from the system. After white sharks declined and disappeared from standardised surveys, Cape fur seals and seven-gill sharks increased in relative abundance, while small fish used by seals and smaller benthic sharks eaten by seven-gills declined. The researchers were careful to say the exact reasons behind white shark loss in False Bay are complex, with shark control removals and likely contribution from shark-eating orcas among the factors discussed. But the broader lesson is still useful here. Fear and predator loss do not stay neatly contained within one species. They travel outward through behaviour and abundance. When the wrong animal leaves, the rest of the system begins to move. Orcas sit at a level where they can trigger exactly that kind of movement. They are not just another participant in the food web. They are one of the animals that can pull on it hard enough for multiple layers to shift. Perhaps the most elegant and unsettling demonstration of fear-driven behaviour comes from beaked whales. These are deep-diving toothed whales that live so far below the surface that much of what they do feels almost secretive by default. Yet research on Blainville's and Cuvier's beaked whales found that group members synchronize their vocal foraging dives with extraordinary precision, overlapping vocal time by about 98%. They then perform coordinated silent ascents in unpredictable directions, covering on average around 1 kilometre horizontally from the place where they stopped clicking before surfacing. According to the study, this tactic sacrifices roughly 35% of foraging time, but reduces the risk of interception by killer whales by an order of magnitude, lowering the group's temporal availability for acoustic detection to less than 25%. It is difficult to imagine a clearer example of fear shaping a life. These whales are not simply diving for food. They are diving around the possibility of being overheard by orcas. Their schedule, their silence, and even the geometry of their ascent have all been bent by the threat of a predator they may meet only rarely. That last point is especially important. Predator encounters do not have to be common to be powerful. If the cost of getting the response wrong is death, then even infrequent danger can mould behaviour over evolutionary time. The beaked whale study makes this plain. These whales give up feeding opportunity to reduce detection risk, and they do so through a coordinated group tactic that seems built around evading killer whales that may be listening for them. In other words, orcas do not have to patrol every canyon and every feeding ground every day. Their reputation is enough to shape the habits of animals living far below the waves. This is one of the reasons the ocean's fear of orcas feels so large. The predator's direct range is one thing. The radius of its influence is another, and that radius extends into decisions about when to make sound, how long to feed, and where to surface after a dive. That is not ordinary predator-prey tension. That is deep behavioural architecture. Large whales show the same pattern in a different way, especially mothers with calves. Research on North Atlantic right whale mother-calf pairs found that they use acoustic crypsis, reducing the number of higher amplitude long-distance calls compared with other demographic groups. The idea is straightforward and rather grim. A mother and calf staying quieter are less likely to advertise their position to eavesdropping predators such as killer whales. Similar work on southern right whales has described low output, infrequent calls and close physical proximity between mothers and calves as a way of reducing detection risk. Again, the remarkable thing is not that whales can be quiet. It is that giant animals in open water appear to manage their own communication because a predator may be listening. Even before an orca is visible, the possibility of one can shrink the soundscape around a newborn. It can make a nursery quieter than it would otherwise be. And in the ocean, where sound carries so well, silence is not emptiness. Silence is strategy. The same logic appears in where large whales choose to spend time. Along the coast of Patagonia, southern right whales shifted habitat use over decades, abandoning the area with the highest occurrence of killer whales and moving into adjacent bays. That is a profound ecological decision. The giant whale population does not gradually alter preferred nursery space because it has become indecisive. It does so because the balance between safety and other needs has changed enough to justify a move. The adults are large, certainly, but the calves are not. Killer whales do not need to threaten every individual equally in order to reshape the behaviour of the whole population. They only need to make some places too risky for mothers to trust. Once that threshold is crossed, the coastline itself starts to look different. One bay becomes acceptable. Another becomes a place where you do not linger with a newborn if you can avoid it. Fear, then, is not just a feeling under the surface. It becomes geography. Humpback whales reveal another side of the same pressure. In a review of 115 humpback killer whale interactions, humpbacks initiated the majority of interactions, and when mammal-eating killer whales approached humpbacks directly, they attacked 85% of the time and targeted only calves. Humpbacks often mob attacking orcas, sometimes even when the victims belong to other species. This is usually described as defensive or anti-predator behaviour, and it makes sense in that light. A species that has lived under repeated killer whale pressure especially pressure focused on calves, may benefit from rushing toward the sounds of a predation event rather than ignoring them. So fear does not always look like retreat. Sometimes it looks like aggression. Sometimes it looks like a giant whale hurling itself into a situation precisely because experience has taught it that failing to respond could be worse. That is still fear beneath the surface, only in this case the fear has been transformed into a willingness to fight before the danger gets too close. What all of these examples have in common is anticipation. The shark leaves before the attack reaches it. The beaked whale stops clicking before the predator can home in. The right whale lowers her acoustic profile before the calf becomes a target. The humpback charges in before the calves are isolated. The southern right whale population shifts habitat before the nursery becomes too costly. This is the ocean's version of looking over your shoulder, locking the door early, or crossing the street before trouble reaches the corner. Except underwater, the costs are larger, the consequences are harsher, and the animal making everyone nervous may be several tons of coordinated mammal moving through the dark with its family. There's also a physiological side to all of this, even when it is harder to measure directly for orca prey systems. In many animal communities, chronic predator risk can change stress hormones, movement patterns, time budgets, and reproductive success. The broad ecological principle is that fear has energetic costs. If you feed less because a predator might be nearby, you gain less energy. If you spend more time grouped tightly, or travelling farther to safe water, you burn more energy. If you keep calves close and quiet, that may improve survival, but alter social contact and behaviour. In False Bay, for example, the loss of white sharks coincided with reduced stress levels in Cape fur seals and changes in their rafting behaviour. That study was about shark decline rather than direct orca fear in seals, but it illustrates the wider principle beautifully. Predators leave signatures not just in carcasses, but in bodies that are still alive, feeding differently, moving differently, and carrying different levels of stress. There is every reason to think killer whales produce the same sort of invisible accounting in species that live with them, and fear can spread socially too. A pod of prey animals does not need each member to learn separately through personal catastrophe. One animal bolts, the others follow. One mother adjusts her route, calves grow up on that route. One population experiences repeated attacks, and future generations inherit the resulting habits as if they were simply the normal way to live. This is especially relevant in marine mammals, which often have long lives, strong bonds, and socially transmitted behaviour of their own. A humpback calf defended from killer whales may later become an adult that responds quickly to attack sounds. A right whale raised in quieter mother-calf conditions may continue those low-output habits. A beaked whale group synchronised by risk will likely keep that synchrony because it works. Orcas are not the only species in the ocean with memory. They're simply the ones so effective at making memory necessary. That may be why the fear around them seems to belong to the whole sea rather than one narrow prey category. It appears in deep divers, in surface mothers, in sharks, in nursery habitat, in feeding schedules, in sound use, in migration bottlenecks, and in how one predator responds to another. It is not one dramatic story repeated endlessly. It is many small adjustments adding up into a broad pattern. Some animals move less boldly, some speak more softly, some feed elsewhere, some gather closer, some fight sooner. Taken one by one, each response seems local and practical. Taken together, they describe an ocean that has learned how costly it can be to ignore an orca. And there is something almost eerie about how much of this remains invisible to us unless we look carefully. A tourist boat may see a calm sea and assume all is well. A camera may catch only a surfacing fin and miss the entire chain of altered behaviour spreading through the area below. A quiet mother-calf pair may look peaceful when in fact their silence is a strategy. A vanished shark may simply seem absent unless you know why absences matter. This is one of the reasons the orca's influence can be underestimated by anyone watching only for dramatic attacks. The real story often begins in the ordinary-looking moments, in the route not taken, the call not made, the dive cut short, the feeding ground abandoned. Fear beneath the surface is not theatrical most of the time, it is efficient, which is, in its own way, even more impressive. Any predator can be frightening at the moment of contact. The rare predator is the one that can organise a marine community around its possibility. Orcas do that. They do it through direct predation, certainly, but also through memory, reputation, and repeated proof that caution is worth the trouble. They turn other animals into planners. They make the ocean listen differently. They make silence useful. They make distance meaningful. And once you understand that, the sea begins to look less like a place filled with random separate lives, and more like a place in which one hunter's presence can alter the decisions of creatures miles away and minutes before anything visible has even happened. That, in the end, may be the clearest sign of true dominance. Not just the ability to win a fight, but the ability to shape behaviour in your absence. Orcas do not need to patrol every corner constantly. They do not need to attack every animal that notices them. The sea has already done much of the work on their behalf. It remembers, it adjusts, it leaves, it hushes itself. And when a predator can draw that kind of response from sharks, whales, and deep-diving specialists alike, what you're seeing is more than hunting success. You're seeing intelligence turned into ecological pressure, which is exactly where this story begins to move next. Because once fear has spread this widely, it raises an even stranger question about the animal creating it. What sort of mind sits inside a predator that does not merely kill well, but reorganises the behaviour of the ocean around its arrival? By the time you have followed an orca through enough of its habits, the usual words start to feel slightly inadequate. Strong is true, but incomplete. Fast is true, but not especially revealing. Social is true, but still not the whole picture. Even intelligent, while certainly fair, does not quite capture the particular feeling of an animal that can learn, imitate, remember, coordinate, teach, adapt its calls, pass down hunting traditions, and in some populations preserve those traditions for decades. What makes the orca's intelligence strange is not that it resembles ours in every way. It does not. What makes it strange is how thoroughly it is woven into the life of a predator. The mind is not sitting off to the side as a pleasant extra. It is inside the hunt, inside the family, inside the dialect, inside the route choice, inside the way one generation leaves instructions for the next. And when intelligence gets built that deeply into a body already capable of outrunning, overpowering or outthinking so many other animals, the result feels less like a clever creature and more like a fully organised force. A good place to begin is with the simple fact that killer whales do not live like solitary machines. NOAA describes them as highly social animals that often live in stable groups, and in many well-studied populations those groups are built around matrilineals, with offspring remaining closely associated with their mothers for life. That means an orca is not born into a temporary crowd. It is born into a long-running society, and long-running societies do something extremely important for intelligence. They allow knowledge to accumulate. A young whale does not just inherit genes. It inherits company, routines, local prey preferences, movement habits, call traditions, and very likely a great many lessons that never need to be spelled out, because they are simply lived again and again in front of it. Intelligence in that setting stops being just an individual property. It becomes something distributed through the family. That is one reason the orca's intelligence feels so different from the intelligence of an isolated problem solver. We tend to admire cleverness as if it is a flash, a single bright answer in one head. Orcas suggest something heavier and more durable. Their intelligence seems to live in continuity. One whale remembers a route, another knows a prey handling method, an older female leads during difficult years. Younger whales absorb calls and habits that will still matter long after their mothers die. The pod, in other words, is not merely a group of smart individuals. It is a memory system moving through the sea, and once a predator can carry memory in that collective way, it becomes harder for the rest of the ecosystem to rely on its usual safety of forgetting. The orcas do not have to rediscover everything each season. Much of it is already there, waiting inside the relationships. The research on post-reproductive females makes that especially clear. A PNAS study found that post-reproductive killer whale grandmothers significantly improve the survival of their grand offspring, and related work has shown that older females often lead group movement in salmon foraging grounds, especially in years when prey is scarce. That combination is extraordinary. It suggests that old age in an orca is not simply a slow fade from the practical business of life. It can be a repository of ecological knowledge with measurable benefits for younger kin. In human terms, we might call that wisdom, though science usually prefers plainer language. Either way, the effect is the same. A family that keeps its experienced elders can make better decisions when conditions worsen. For a predator, that matters immensely. In a hard year, the sharpest teeth in the world are less useful if you do not know where to look. Then there is vocal learning, one of the clearest signs that the orca mind is flexible rather than rigid. A natural experiment documented by researchers found that juvenile killer whales separated from their natal pods changed aspects of their vocal behaviour, supporting the conclusion that killer whales are capable of vocal learning. Later work in the Proceedings of the Royal Society B went even further, showing that a killer whale could imitate novel sounds made by conspecifics and humans, including human-like utterances such as hello and bye-bye, as well as other unfamiliar sounds. No one sensible should turn that into a fairy tale about chatty whales trying to become sea comedians. The real point is much more important. Orcas can hear a sound that is not part of their standard repertoire and attempt to reproduce it. That kind of imitative flexibility is rare and deeply useful in species with culturally transmitted vocal traditions. It means the pod's acoustic world can be learned, adjusted, and preserved through copying rather than being fixed like a wind-up toy. And they do not only imitate sounds. Experimental work on body imitation found evidence that killer whales can copy novel motor actions in a do-as-other-does style paradigm, supporting the idea that imitation may underpin some of the group-specific traditions seen in the wild. That matters because cultural behaviour becomes much easier to maintain when an animal can copy both what another individual sounds like and what it does. A hunting tactic is not passed down only through luck or instinct. It can be observed and reproduced. A body position, a rush pattern, a tail move, a timing decision, all of these become easier to preserve if the younger whale is not simply improvising but actually learning from what it sees. This is one of the reasons orcas feel so educational in the most alarming possible sense. The pod does not just act, it demonstrates. This leads naturally into culture, a word that once made some people uneasy when used for non-human animals, and now feels increasingly difficult to avoid in the case of killer whales. NOAA explicitly states that diet in killer whales is determined primarily by the culture of each ecotype, meaning learned hunting tactics, and broader work on cetacean culture has pointed to the highly conservative socially learned traditions of killer whales as one of the clearest examples of animal culture outside our own species. Residents keep fish-focused lifestyles. Big's killer whales focus mainly on marine mammals and squid. Distinct groups carry distinct call repertoires, hunting methods, and social habits that persist over time. That means an orca is not just an animal equipped to think, it is an animal shaped by inherited ways of thinking and doing within its group. And once culture enters the picture, intelligence becomes less about raw mental horsepower and more about what a community can preserve, refine, and hand onward. There is something especially striking about how conservative these traditions can be. Orca populations living in overlapping regions do not necessarily merge into one blended style just because the opportunity exists. Instead, they can remain behaviourally distinct for long periods, keeping different diets, calls, and social preferences. That is not what one would expect if every killer whale were simply responding to the same environment in the same automatic way. It suggests that social identity matters, that belonging matters, and that once a group has a successful way of living, it can become something worth maintaining even when other options are nearby. Intelligence in that setting is not just adaptation, it is fidelity. The orca is capable of changing, yes, but also capable of preserving. Those are different abilities, and together they create a much richer picture of mind. The brain itself supports that larger picture, though one must be careful not to treat brain size like a magic trophy. A major review in PLOS Biology concluded that cetaceans have large, complex brains consistent with complex cognition, and later neuron count work reported that the killer whale had more cortical neurons than any mammal measured in that particular data set. That does not mean an orca is smarter than every other animal in some neat universal ranking, which is not really how cognition works anyway. But it does reinforce the idea that we are not dealing with a simple nervous system attached to a large body. We are dealing with an animal whose neural architecture is substantial, and whose behaviour in the wild already points strongly toward complex processing, memory, social learning, and flexible communication. The anatomy does not prove everything by itself, but it certainly does not weaken the case. There is also suggestive evidence from mirror work. A study on mirror image processing in marine mammals found that killer whales appeared to possess the cognitive abilities required for self-recognition. That wording is worth keeping exactly as careful as the researchers intended. It is suggestive rather than a final, triumphant stamp of human-like self-awareness. Even in species where mirror studies are famous, interpretation can be tricky. Still, it matters that killer whales showed mirror-related behaviour substantial enough for researchers to make that claim. At the very least, it adds one more piece to a growing pattern in which orcas do not behave like animals limited to crude reflex and routine. They investigate, differentiate, and process information in ways that invite serious cognitive respect. Perhaps even more compelling than any one cognitive test is the way orca intelligence appears in the structure of daily life. Sound is used differently depending on prey. Fish-eating killer whales are typically far more vocal, whereas mammal-eating killer whales often stay comparatively quiet, likely because marine mammal prey can hear and react to them. That means the orca is not merely capable of making sounds, it is capable of adjusting the social and sensory style of the hunt to fit the problem in front of it. The pod knows, in effect, when being loud is useful, and when being quiet is wiser. That is not grand abstract reasoning. It is better than that. It is practical intelligence, the kind that pays its way in calories and survival. The same practical quality appears in innovation. A 2022 study on killer whale innovation in managed care found that the whales demonstrated fluency, originality, and flexibility when cued to invent novel behaviours. One should not drag captive results too casually into the wild, because context matters, and managed environments are not open oceans. But the finding is still interesting. It suggests that orcas can respond to a problem not merely by repeating one practice solution, but by generating varied responses. When placed alongside their known wild behaviour, the implication is not that orcas are random creators of endless novelty. It is that they seem capable of behavioural flexibility when the situation rewards it. In a predator, that flexibility can be particularly potent. It means the animal is not trapped inside one narrow script, and yet what makes their intelligence strange is not only flexibility, it is the balance between flexibility and order. Orcas are not all improvisation. They are also pattern, ritual, repetition, clan, repertoire, inherited diet, preferred associates, long memory. In some ways, they look less like chaos made clever and more like discipline made alive. The pod can stay together for years. Calls remain stable over long periods. Older females lead. Cultural distinctions persist. New behaviours can spread socially, but not necessarily to everyone at once or in the same degree. Intelligence here is not just the ability to invent, it is the ability to manage invention without losing the social shape of the group. That is a higher and frankly more intimidating order of cognition than simple cleverness. A recent 2025 study on killer whale use of fishery catches adds a fascinating modern example. The researchers found that both independent learning and social learning contributed to the acquisition of this new feeding behaviour, and that social preferences influenced how much different individuals engaged in it once it had been learned. This is exactly the kind of thing that makes orca intelligence feel so contemporary and difficult to pin down. They are not merely preserving old traditions untouched by the modern world. They can also incorporate new opportunities, and social dynamics help shape who adopts them and how strongly. The mind of the orca, then, is not frozen in some noble prehistoric purity. It is active, responsive, and quite capable of adjusting to human-altered conditions, which is fascinating for science and mildly unsettling for anyone hoping apex predators might politely ignore novel openings. There is another side to all this that often gets overlooked. Intelligence is not just what helps an orca catch prey, it is also what helps it survive social life. Stable groups require conflict management, recognition, care for young, attention to rank and affiliation, and the ability to function in close quarters without everything dissolving into constant wasteful tension. A 2019 study on killer whales of the Crozet Islands emphasized how strongly sociality affects individual fitness and survival in this highly social species. That means the orca mind is not devoted only to hunting. It is also occupied by the very demanding work of belonging. If you live in a long-term family where cooperation matters and where learning travels through relationships, then social awareness is not a luxury. It is part of basic competence. This may help explain why people often feel something slightly uncanny when watching orcas. It is not just that they look powerful. Many animals look powerful. It is that their behaviour hints at interior organisation. A shark may terrify through efficiency. An orca can terrify through efficiency, plus apparent deliberation. There is a difference between being pursued by an animal that is extremely good at being that animal and being pursued by an animal that also seems to belong to a society with memory, roles, variation, and transmitted skill. Even when we are careful not to project too much, the feeling remains. The intelligence looks inhabited. The predator does not seem empty behind the eyes. But perhaps the strangest thing of all is that none of this makes the orca less wild. Sometimes people assume that intelligence softens an animal into something more familiar and less severe. Orcas refuse that comfort. Their complex cognition does not reduce their status as apex predators. It sharpens it. The memory helps the hunt. The culture helps the hunt. The vocal learning helps pod cohesion, and pod cohesion helps the hunt. Older females help grand offspring survive, which helps the lineage persist. The same traits that make the species socially fascinating are also the traits that make it ecologically formidable. In the orca, the beautiful and the frightening are not separate departments. They work together. So when we talk about the strange intelligence of an apex predator, what we really mean is this. The orca does not dominate only through force. It dominates through organised thought expressed socially, through learned calls, through inherited diets, through imitation, through leadership, through silence when silence matters, through a brain and a body that seem to have made a long-term agreement about what success should look like. That is why the intelligence feels strange. Not because it is mystical, but because it is so thoroughly practical and yet so socially deep. It makes the orca seem less like one animal ending another animal's day, and more like a culture of predators moving through the sea with a shared understanding of how to do the job. And once you see them that way, the final step in the story becomes easier to understand, because the ocean does not fear orcas only for one reason. It fears the whole combination: the body, the pod, the memory, the tactics, the silence, the speed, the voice, the elders, the learned methods, the way one generation sharpens the next. Which is why, before this quiet journey is done, there is one larger picture left to settle into, and it is the one that gathers all the others together. Not just why orcas are feared, but why they have come to feel like the sea's clearest expression of power. If you spend enough time looking at the ocean, one thing becomes very clear. Rule is not the same as size. It is not the same as ugliness, sharpness, or public reputation either. The ocean is full of animals that look terrifying in photographs and underperform once the wider ecological picture comes into view. It is also full of animals that seem almost gentle until you learn what they can do when conditions suit them. Orcas sit in that second category only for about 3 seconds, because the moment you actually begin paying attention, the full pattern starts to emerge. They are powerful, yes. They are fast, yes. They are armed, social, adaptable and smart, all true. But what makes them feel like the sea's darkest shadow is the way those qualities overlap so completely that almost nothing in the marine world can afford to ignore them. Orcas do not dominate the ocean because they are the biggest thing in it. They dominate because they are one of the few things in it that can turn so many different kinds of advantage into one working system. That is the detail that keeps returning no matter where you look. If you focus on the body, you find speed, thrust, stability, counter-shading, endurance, heavy jaws, and teeth built for gripping and tearing. If you focus on the senses, you find excellent hearing, echolocation in many contexts, and the ability to use sound strategically depending on prey type. If you focus on the social life, you find stable matrilines, older females leading in hard times, food sharing, cooperative movement, and learned traditions that outlast any one individual. If you focus on the hunt, you find waves used against seals, tail slaps used against fish, silence used against marine mammals, and precision used against sharks. Very often in nature, one great strength comes with a weakness somewhere else. The orca seems to have spent a great deal of evolutionary time negotiating unusually favourable terms, and because all those strengths sit inside the same animal, the effect on the rest of the ocean is broader than the effect of almost any single marine predator. A fish specialist may terrorise fish and mean little to whales. A seal hunter may alarm pinnipeds and never trouble sharks. A deep diver may be formidable in darkness and irrelevant near the surface. Orcas do not stay inside one narrow lane. Different populations specialise in different prey, and across the species the recorded prey list exceeds 140 species, ranging from fish and squid to sharks, rays, seabirds, seals, dolphins, porpoises, and large whales. NOAA notes that their diet is determined primarily by the culture of each ecotype, meaning learned hunting tactics pass through the group, and PLOS ONE's global review emphasises just how wide the total prey range really is. So when people say the entire ocean seems to know orcas, there is solid reason for it. So many different kinds of animals have had reason to learn the lesson. That lesson is not simply that orcas can kill. Plenty of predators can kill. The lesson is that orcas can decide how to kill, and more importantly, when not to rush. They can herd when herding works. They can stay quiet when stealth matters. They can manipulate the environment when prey has found temporary refuge. They can target calves instead of adults, livers instead of whole carcasses, vulnerable positions instead of brute force confrontations. In Antarctic observations, killer whales reduced and destabilised ice flows before wave-washing seals into the water. In Norway, carousel feeding groups herded herring into dense schools and stunned them with tail slaps. In Patagonia and at the Crozet Archipelago, intentional stranding has been documented as a technique for taking prey from shorelines, with evidence strongly suggesting social learning and apprenticeship. None of that looks like a simple predator following a single instinctive script. It looks like a species that keeps building practical local knowledge and then holding on to it. This is why the fear surrounding orcas feels different from the fear surrounding so many other ocean hunters. A shark may frighten because it is sudden. A giant squid may frighten because it is strange. A crocodile may frighten because it looks like an old argument against evolution having any sense of moderation. Orcas frighten because they seem competent in several categories at once, and competence at that level creates uncertainty. If you are prey, you cannot rely on one simple weakness. You cannot say, well, at least they are solitary, at least they are noisy, at least they only hunt one thing, at least they only work in one habitat, at least they tire quickly, at least they are too small for this, at least they are too specialised for that. The orca removes too many of those reassurances. It leaves the rest of the ocean with a more difficult truth. The threat can arrive in multiple forms, from multiple directions, carrying local experience you may not even fully understand yet. That uncertainty is part of what makes them ecologically dominant even when they are not physically present. We have already seen how brief visits by killer whales can drive white sharks from productive hunting grounds in California for the rest of the season, and how direct predation in South Africa was followed by immediate shark flight and prolonged local absence. We have also seen that mother-calf pairs of right whales reduce conspicuous calling, that beaked whales coordinate silent ascents to reduce killer whale interception risk, and that southern right whales in Patagonia shifted habitat use away from areas with more frequent orca occurrence. These are not all stories about animals being eaten. They are stories about animals changing behaviour because being eaten is sufficiently possible. That is a much wider kind of rule. It means the orca does not only control outcomes through force, it controls them through anticipation, and perhaps that is the real mark of power in nature. Not merely the ability to overpower something in direct combat, but the ability to alter what other animals do in your absence. A predator with that influence does not need constant contact to remain important. Its reputation does part of the work. Its previous successes do part of the work. Its prey's memory does part of the work. The ocean becomes quieter, shallower, more clustered, more evasive, more cautious, simply because orcas exist within it as a credible possibility. White sharks leaving a feeding site, beaked whales sacrificing foraging time, and mother-calf right whales reducing vocal output all point toward the same conclusion. The sea is not only responding to orca mouths, it is responding to orca probability. There is also something quietly extraordinary about how orcas combine social life with predation, without either one seeming to weaken the other. In many animals, strong social demands can become a burden. Groups need coordination, food sharing, compromise, stable relationships, and time spent maintaining cohesion. Orcas appear to turn all of that into an advantage. Stable family lines preserve hunting knowledge. Dialects help maintain social identity. Older females guide movement and foraging, particularly when prey is scarce. Food sharing can support kin. Vocal learning and imitation help keep traditions alive. That means their intelligence is not floating above their ecology, as some abstract trait we admire from a distance. It is directly plugged into survival. Even the oldest females, long after reproduction has ended, remain valuable through ecological knowledge that improves descendant survival. A pod is not simply stronger because it is larger. It is stronger because it remembers together. That memory changes the usual balance between predator and time. Many hunters must constantly start over. One generation succeeds, dies, and leaves the next to rediscover whatever it can. Orcas do not seem nearly so wasteful. Their matrilines can carry routes, calls, prey preferences, and tactics across decades. Studies of resident killer whales have shown vocal dialect stability over many years, while work on hunting behaviour, intentional stranding, and prey specialisation points to social transmission across generations. So when a local pod becomes good at a thing, that skill can stay in circulation. The ocean, in effect, is not merely dealing with a predator species. It is dealing with long-running lineages of specialists. That makes orcas feel less like isolated animals and more like mobile traditions with teeth. It also explains why they seem so at ease at the top. Confidence in a predator can come from size, but it can also come from reliability, and orcas appear to have that in abundance. Their bodies work, Their social systems work, their calls work, their tactics work, their regional traditions work, even their silence works when silence is the better option. Mammal-hunting killer whales call much less than fish-eating populations, likely because marine mammal prey can hear them and respond. That is such a wonderfully practical adjustment. It says, in the plainest possible way, that the orca does not care about one fixed identity. It cares about effectiveness. If effectiveness requires noise, it uses noise. If effectiveness requires quiet, it uses quiet. A great many marine animals would probably appreciate it if killer whales were more emotionally attached to consistency and less attached to results. They do not seem to be. And for all of this, they are not reckless tyrants of the sea. That is worth remembering, because the temptation with apex predators is to turn them into cartoon villains. Orcas are not that. They are selective. They calculate risk through behaviour, if not conscious mathematics. They often target calves rather than healthy adults among large whales. They focus on profitable organs in sharks. They use tactics that reduce uncertainty and wasted effort. They break off attacks when defence becomes too costly. The point is not that they are unstoppable. The point is that they are unusually good at recognising where the best odds lie. That is far more important in ecology than swagger. A predator that chooses its moments well will rule longer than one that lunges at everything like an overconfident fool with very expensive teeth. Still, even their caution adds to their power. A reckless hunter can sometimes be outlasted. An efficient hunter is another matter. White sharks may flee after brief killer whale visits precisely because the sharks are not dealing with chaos. They're dealing with a threat that can kill them and has reason to do so. Mother whales cluster around calves because they are not facing random harassment. They are facing predators known to isolate and drown the vulnerable. Beaked whales synchronize their silent ascents because the danger is not abstract. It is a listening, mobile, intelligent predator that can turn sound into interception. Once again, the orca's rule emerges not from simple brutality, but from the way intelligence sharpens brutality into something more reliable. Perhaps the strangest part of all is that orcas remain beautiful while doing this. There is no practical ecological reason why one of the most formidable hunters in the ocean should also look so cleanly designed. The black and white pattern is striking. The movement is smooth. The surfacing is elegant. Even the dorsal fin, which in adult males can reach about 1.8 meters, has the visual effect of a banner rather than a warning label, though it functions as part of the animal's stability in the water. This creates a peculiar mismatch in the mind. We are used to imagining menace as ugly, heavy, or grotesque. Orcas complicate that expectation. They can look calm and almost ceremonial even while carrying one of the most complete predatory toolkits in the marine world. That contrast may be part of why they hold attention so strongly. They do not advertise their danger with frantic disorder. They carry it with composure, and because they carry it with composure, they often seem to belong to the sea at a level few other predators manage. Sharks are ancient and extraordinary certainly, but many are solitary. Large whales are majestic, but many are vulnerable when young. Seals are quick, but they need refuge. Fish are abundant, but abundance is not command. Orcas move among all of them as a kind of mobile verdict. They can enter seal water, shark water, whale water, fish water, ice water, coastal water, open water, and still remain recognisably themselves. NOAA describes them as cosmopolitan apex predators found in all oceans. That global reach matters symbolically as much as biologically. It makes the orca feel less like a local king and more like a species whose authority travels. To say they rule the ocean, then, is not to pretend they control every square metre of it, or face no danger or limit. That would be silly. The sea is too vast, too variable, and too indifferent for such simple slogans to be literally true. Orcas can be injured, they can fail. Some prey escape, some adults fight them off. Some regions are harder than others. Human-caused threats, from prey depletion to noise and contaminants, can affect them significantly. especially endangered populations like the southern residents. Rule, in ecology, rarely means perfection. It means influence. It means the capacity to shape the behaviour of others, to exploit many kinds of opportunity, and to sit so high in the network of risk that even other hunters respond to you with caution. By that standard, orcas are among the clearest rulers the sea has produced, and maybe that is why they seem to cast such a long shadow over the imagination. They are not simply one more dangerous animal among many. They are a reminder that nature sometimes builds combinations that feel almost unfair. A dolphin's family structure, a heavyweight's power, a strategist's patience, a hunter's mouth, a memory system carried through generations, a voice rich enough to preserve identity and flexible enough to adapt, a willingness to specialize without becoming trapped by specialization at the species level. All of that in one black and white body moving through a medium where most creatures have nowhere solid to stand. It is no wonder the ocean reacts the way it does. The orca is not only dangerous in the immediate sense, it is structurally dangerous. The danger is built into the whole design. So, when people say the sea's darkest shadow, that phrase begins to make practical sense. A shadow does not need to strike every moment to matter. It only needs to fall across a place and change how that place behaves. Orcas do exactly that. They darken feeding grounds for sharks. They darken nursery waters for calves. They darken the acoustic world for right whales and beaked whales. They darken haul-outs, migration bottlenecks, ice edges, and schooling fish above cold northern waters. Not because they are evil, and not because the ocean is engaged in melodrama, but because repeated success has made their presence a meaningful fact in the lives of other animals. The shadow is ecological. It is made of memory, avoidance, silence, and sudden departure. And yet, in a softer way, there is something deeply fitting about them too. If the ocean is going to have a ruler, perhaps it makes sense that the role would not go to the biggest body or the longest tooth alone. Perhaps it would go to something able to combine force with knowledge and movement with family. Something that can live in many seas, speak in learned dialects, follow old matriarchs, and still burst into speed when the moment demands it. Something that reminds us that true dominance in nature is rarely simple. It is usually a layered thing, made from many small efficiencies held together over time. Orcas happen to be one of the clearest examples of that principle ever shaped by water, and that is why the rest of the ocean seems to treat them with such serious respect. Not because every animal has been attacked, not because every encounter ends in disaster, but because enough encounters, across enough oceans, over enough generations, have produced the same conclusion. When orcas arrive, the calculation changes. The shark reconsiders. The calf stays closer. The mother goes quieter. The deep diver surfaces elsewhere. The seal watches the ice edge differently. The whole sea shifts, if only a little. And in the language of nature, where fear is practical and memory is earned, that is about as close to ruling as anything gets.